Hello, I welcome you to this ultimate Kotlin programming series. This course will provide you with everything you need to know for all things Kotlin and mobile development. My name is Farhan Hussain and I will be leading you through this amazing course. I have experience in creating over 3,500 video tutorials in a wide array of subject areas from game development to web development. I have personally created a video from Solar Systems for the past 6 years, which is the world leader in providing online education. I also run an online education platform and teach programming as a lecturer. I'm also a three-time published author of programming books and have over 250,000 students enrolled on my courses on Udemy. Yes, you heard that correctly, over 250,000 students. That's just on Udemy. I also have millions more that have watched my courses on a variety of other platforms. I created this course for anyone interested in learning more about Kotlin, mobile development, and programming for that matter, plus its implementations. Also, for anybody looking to refresh their Kotlin knowledge and programming skills in general. The ideal student for this course is anyone with a passion for learning more about the increasingly large Kotlin programming market and its plethora of applications such as Android apps. Feel free to take a look through the course description, ask any questions you may have before enrolling. I am so confident you will love and benefit from my course that I am providing a 30-day money-back guarantee. Thank you for listening, and I look forward to seeing you inside. Hello, in this video I am going to show you how to set up Kotlin, the programming language, on a Windows machine. If you're interested in it for Linux or Mac, for example, I've got videos covering that, so feel free to check them out. Okay, so first of all, you want to open up a web browser, and if we just go to Google Kotlin and go to kotlinlang.org. This is a great website. It allows you to, there's a lot of resources on here. But if you scroll down, go to this little section here. We're going to be using the IntelliJ IDEA to, run our Kotlin code. You can run it using Android Studio. That's assuming you're going to be doing, Android apps. You're going to be using Eclipse by installing the plugin. Eclipse is very popular, so if you want to go down that route, that is fine. Or you could just be compiling it via terminal or command line depending on your operating system. I'm choosing IntelliJ simply because IntelliJ is created by JetBrains. JetBrains are the developers of the Kotlin programming language. So if we go to instructions and just download the community edition, so I'll provide links to everything, don't worry, and just download this exe right here. And so we're just gonna wait for that to download, and then we'll be doing the we'll be doing IntelliJ. While that downloads, one other thing that we're gonna need is the JDK. I've already got it installed, but let me just show you. So if you go to Google JDK, go to here, and let me just accept these cookies. Go to right here, download the latest version, and then if you scroll down, click accept license agreement and just download which version you want. It'll be the Windows 64-bit version .exe. Install this before you install, actually it doesn't matter, you can install this first and then this, but some of the steps for this requires the JDK, mainly the setup or the creation stage of our project. So JDK is the Java development kit, which has the regular sort of Java in there that allows you to run Java applications, but it also provides the tools that you need to develop and test Java applications. Kotlin is compiled on a Java-based compiler, hence why we need it. So just download the JDK. Chances are you probably already got it if you're into development. So, but if not, this is where to go. But like I said, I'll provide a link to everything. This is almost done, another 20 seconds or so, and then it will be done. A few more seconds, and then we can open this bad boy up. 8 more seconds. 7, 6, 5, 4, 3, 2, 1. done. Almost. And almost. And if we just click this, open it up. So just click yes. And so this is the setup. So just click next and just install it wherever you want to. I'm going to change the directory. I'm going to change it to, go to PC. Let's change it to D drive, software, and I'm going to install it there. But you can choose where you want to install it. Click next, and you can create a desktop shortcut. You can create a context menu as well. You can, change all of this stuff. You can download and install JRA as well, which is essentially, part of the JDK aspect of it. But if you do the JDK manually, then you don't really need to do this. So add launchers directory to the path. You can do that if you're, doing certain types of compilation. It'll be required, but for the most part, we can leave it. Click next, click install, and this won't take very long. Once it's installed, we can actually create a Kotlin based project, and I'll just show you how to run it. In other videos, I'll cover all the different features that the Kotlin programming language provides, such as variables, functions, all of that good stuff. So luckily for us, we only have to do this, this step once, and then we're all good to go. Okay, so while this, extracts, installs, etc., I'm just gonna put the mic on mute, but I'll unmute it when we're ready to go. Okay, so it's all done, and we can just click the run button, click finish. I'll close the web browser down. We don't need that anymore. And you can import settings if you have a previous, configuration. I don't, so I'm just going to click OK. Just accept the privacy policy, click continue. I don't want to send any of my data. It's your choice if you do want to. You can choose the theme. I'll select the dark version. Click just next default plugins. And I'm leaving everything as default. You can customize it, disable it and whatnot, but we can leave it as default. Featured plugins, and again, you can change this if you know what you're doing. Otherwise, just go to start using IntelliJ IDEA, and we're almost there now. We're literally at the point where we can create a project. Go to create new project, and you want to select Kotlin. For the project SDK will be your Java project. I mean your JDK version. So if you just select that there, and if it says nothing available, then you just have to make sure you go ahead and download it. So Java, Kotlin JVM, your project SDK, click next. Title it something. I'm going to say setup. I'm going to go to desktop. So I'm going to go to my desktop and install it there. So I'm going to have to go to users and go right here, desktop. I'm going to type in /setup, click OK. I just need to create the folder, sorry. So if I type in setup, there we go, click OK. Folders appeared there, click finish. This will launch up the IntelliJ part of our project now. So click close, click the project right here, and I go to setup. We need to create a Kotlin file. So right click src, which stands for source, go to new, Kotlin file class. You can name it, I'm going to call it main. And now what we need to do is simply in here write some code. But before I do that, just so it's easier for you to see, I'm going to go to settings. I'm going to go to editor, font. I'm going to increase the font size to 20. Did that change it? I'm not too sure. I was meant to put 24. 24. Click OK. Okay, so it's just a little bit easier for you to see. Maybe you're on mobile, for example. We need to create a default function, which is called main. This is the main entry point of all your applications. So fun is the keyword for function. Then you put the keyword main, open close bracket. Inside here you put args, which stands for arguments, colon, array. And this is an array of strings. Array of strings, so string. Now put some curly braces. This is where all of the code for our application goes. I'm going to put a print line just so you can see it working. I'm going to say hello world. Save that. And before we run it, so what is happening? Keyword function creates function. This is the default main method. This is just some arguments that the application gets from the compiler, when it's actually not the compiler, when it's actually run. So you can actually provide these if you run it, for example, via terminal or something like that, or command line. This is just a requirement. I'll cover this in more depth in a separate video. Curly braces just indicate the starting and the ending code, and anything in between is part of this function, this right here. So we can just go to run, click main KT, and it'll run it, and we'll get the result down here. So just a few more seconds, and there we go. It says hello world, and that's it. It's that simple to download, set up, and create a project for Kotlin using the IntelliJ, the editor. If you have any questions, feel free to pop me a message, and as usual, I look forward to seeing you in the next video. Hello, in this video, I'm going to show you how to, program in the Kotlin programming language on a Mac. So basically the setup stage. If you want to do it on Linux, such as the Ubuntu distro or Windows, feel free to check out those setup videos. Okay, so the first thing we need to do is go to our browser. We need to download, so if you just Google Kotlin, I'll actually provide all the links to everything that we access, but to show you the process of getting to it. So just go to kotlinlang.org, and it's a great website. It has a lot of learning resources. Definitely recommend checking it out. If you scroll down and we go to this little section here, there's a few different ways that we can develop for Kotlin. We can use the IntelliJ IDEA. We'll be using that. I'll explain in a second why. You can use Android Studio. This is, under the assumption that you're going to be making Android apps. You can use Eclipse using a plugin from the Eclipse marketplace. And if you're a big fan of Eclipse and you want to go down that route, because it's very, very popular, the Eclipse IDEs, recommend Eclipse then. And there's instructions right here. The other option is using compiling it yourself via the terminal or the command line, and that's perfectly fine. But the reason I'm choosing IntelliJ IDEA over any of the other methods is because IntelliJ is created by the company JetBrains, and JetBrains are the developers of Kotlin, the programming language that we're going to be using. For that reason, things are just going to work better, and we'll get the latest updates, the latest features, all of that good stuff. Go to instructions and just go to the community edition. Just click that link. I'll provide a link to this directly as well. Just download the community version. If you have access to the ultimate version, maybe via a university, a school, or your company, that is fine, or you've paid for it yourself, the coding is exactly the same. Next, what you want to do while this is downloading is Google JDK and just open this up. Obviously to accept the cookies. Now, just click this download button. JDK is a Java development kit, and this allows us to, run, develop, and test our Java applications. Chances are you probably already got this installed if you're a developer and you had your computer for a while. But if you haven't, recommend downloading and installing this. Actually, you need it. There's no recommendation. You have to do it. Okay, so you go to accept license agreement, select the version. So Mac OS, just do the DMG, which is a nice installer. I'm not going to do it because I've already downloaded and installed it before, like ages ago. But if you just select this, once that file downloads, if you just open it, just go through the setup process. It's really simple, so normal executable. And our file's almost done in less than a minute. And then I'll show you how to install this and how to create a Kotlin-based program. So just a little bit longer, and then we'll be ready to go. So it's gonna have a little drink. I have some tea right here. Let me have a sip of this goodness. Okay, so if we just open up this DMG, and this will let us install the IntelliJ IDE, and it's almost done opening. Now if we just drag this, I like that, IntelliJ.drag to, so it's as if it's a function. That's cool. So we drag that to applications and just wait for this to copy over. It's just a gigabyte. Depending on what sort of drive you got, SSD, flash, that sort of stuff, it will, the speed will vary. Okay, so now what we want to do is close that. We can close this down, and it will be in your, we can actually eject this as well. It will be in your applications folder, and it was in IntelliJ. You can open it from here, or just go to Launchpad, or search it here. Either method is fine. And just open this up, and what we'll do is create our Kotlin project. and then I'll just show you how to run it, and then we're all done. So very simple stuff, not difficult at all. Okay, if you have a configuration, some settings from a previous IntelliJ, installation, feel free to import it. I don't, so I'm just going to click OK. I'm going to click confirm, continue, and don't want to send any statistics, so I'm going to click don't send. And now just select the theme that you want. I like the dark theme, it always looks all hacky and nice. Go to next key maps. So you can use a few different ones. I'll say I've never used IDEA before. I say select this one. It's just it's more adapted to Mac OS X. Click next launcher settings. We can leave that default plugins. You can start removing or disabling these, but for now let's just leave it as it is. Click next feature plugins. Again, you can install some extra stuff. For now we'll just leave it as it is. Start using IntelliJ IDEA and click create new project. Go to Java, go to project SDK, select the version here, and this is basically your JDK version. Go to Kotlin, and from here you click next. You just save it somewhere, so I'm going to go to desktop, save it there. And we don't want to save it directly on the desktop because it'll just create the files there. So we want to do, I'm going to say setup. So I'm going to, yeah, I'll call it Kotlin right now. Project name, you can change that if you want to, but I'll leave that as it is. Click finish. Does not exist, it will be created. That's fine, that's exactly what we want, and it's created it here. So we got some files in here, but before we can actually run it, I'm just going to open this out. We need to right click src, which is a source directory, go to new, Kotlin file class, and just name your file main, for example. You might be thinking, why did we create a Java project? It's because Kotlin is compiled on the Java compiler. That is the reason why. And the code is, you can use the code, you can use a bit of Java and Kotlin, a bit of Kotlin and Java, really cool stuff. And what I'm going to do, before I start coding, go to preferences, go to editor. This is just an optional step, mainly for these videos, just so it's easier for you to see what I'm doing. So I'm going to say 24, that is pretty big now, so you'll be at this sort of file size, and this should be readable on a mobile device. So you just type in fun, which is the keyword for a function. You put main, which is the main entry point of the application. All applications will need this function. How simple or how complex it is up to you. Probably keep it simple, but you all need this. Open close brackets, put args, colon, array, string, and curly braces. I'm going to have separate videos covering all of these individual features, so feel free to check them out. All you need to know is a function called main, the main entry point of the application. We've got some arguments. It's an array of string values, and these are passed in when the application, your application, not IntelliJ, is first run. These are optional, parameters and, command line based parameters, which I will show you in a separate video how to manipulate and use. So if I just put print and then quotation marks, hello world, and if I save that now, we're ready to run. You might be thinking, why am I using semicolon? It says redundant semicolon, and you can remove it as well. The main reason I'm using it, many languages like C#, Java, C, C++, PHP, JavaScript use semicolons, and if the language doesn't enforce semicolons but it allows you to use them, I recommend using them because it's a good habit to get into because many languages require them. So now we just need to go to run, click main KT, which is our file, and now this will run the application and we'll get the output down here, which is just printing at the moment, printing a line directly to the console. Okay, So there we go. Hello world has been run, or the code has. That's it. Simple stuff. If you have any questions, feel free to pop me a message. And as usual, I look forward to seeing you in the next video. Hello, in this video I'm going to show you how to set up and start programming in the Kotlin programming language on a Linux based machine. It could be Ubuntu, it could be another distro. Okay, so what we are going to do is download the IntelliJ IDEA to be able to code in Kotlin. So if we go to Google Chrome and get rid of that, and if you literally just Google actually, if you Google Kotlin, I want to show you something first. Go to kotlinlang.org, so that is their official website. If you scroll down, there's a bunch of resources on here as well, but there's a few different ways that you can run Kotlin. You can use the IntelliJ IDEA, which is what we're going to be using. Use Android Studio, which is under the assumption that you're going to be developing for Android. You can use Eclipse, which is a very popular language, so if you want to go down that route, you can download a plugin for it, or you can compile it using terminal or command line depending on your operating system. Like I said, I want to go down this route. The reason is IntelliJ IDEA is made by JetBrains. JetBrains is the developer of Kotlin programming language. That's the reason why. If you just go to instructions, scroll down and let's go to here, Community Edition. You can go directly to the JetBrains website if you like as well, and just download the Community Edition right here. And I'm going to cancel it because I've already got it downloaded. If you have access to the ultimate version, maybe via your company or university, for example, that's fine. The coding is the same. That's all you need to download. So now, if you go to where we actually downloaded it, go to Downloads, and if you right click and if we just extract it, so if we just extract here, it's a gigabyte file. So depending on how fast your internal drive is, it might take a little bit of time. Mine's an SSD, so not too long. And in here, we want to run the idea.sh within the bin folder. So within the bin folder, we want to run this. So we open up terminal, and what we need to do is type in cd, which is change directory, and we're going to change to the bin directory. If you just drag and drop that on, click enter. Now we want to run the idea.sh to just confirm you're in the right folder. If you type ls, it'll list all the files there. As you can see, idea.sh is there. So if I type in ./idea.sh and I click enter, this will now run the IDE. Okay, so depending on whether or not you've already done this before, because I already did this before the video, just to go through the steps, you may have like a little bit of extra setup to do. All that is it's just asking you, what theme do you want, just some basic stuff, nothing crazy. If you just go through that process, and then you'll land right here. Once you actually get to this stage, we can actually create a new project. So click create new project, and what we want to do is select a Kotlin JVM. We also need the JDK because yeah, we need the JDK, so because it's going to be using that to compile it. So if you just go here and you want to download the JDK, where is the JDK link? So this is just the SE. Oh, there it is. Okay, so if we scroll down, it is Linux, and we'll get the Debian file. So accept license agreement, click that, and this will download. I did accidentally deleted the file, so I need to download it again. Shouldn't take no longer than a minute. Just gonna have a little sip of my drink while I wait, and we'll install this. So this will install not only Java, but the development tools that are part of Java as well. That allows you to develop in Java using other environments such as IntelliJ or Eclipse, for example. So just under a minute now. Almost done, and then we'll be able to install JDK for our system. So almost there, just less than 15 seconds now, less than 10 seconds now. So 5, 4, 3, 2, 1, 0. Here we go. So if we just open that, and this is open the Debian file up. So almost. Minimize this. So it's just launched it up, and if we click install, just type in your password. So this is just going to install the development kit. 16% is done. So again, just be patient, because once you've done this process, that's it. You only have to do once. Now that's installed now. So close that down, and as you see, there's nothing there. So if you just close this, close IntelliJ completely, run IntelliJ again. I just wanted to show you, what it might look like if you don't install it, just so if you ever come across that problem, you know how to fix it. Go to create a new project. As you can see, the JDK version is there, so we just click 11. We need to select Kotlin JVM, and apart from that, we are happy. Don't want to change anything else. Click next. Name your project. So I'm just going to say setup, and now project location. You can change the location if you want, and I'm going to change it to. I'll change it to desktop just so I can easily access it, but that's up to you. And there are some more settings as well. You don't need to mess with any of them at this stage. So if we click finish, and we have our project now created. So if I click this project section, we can see, if we go to desktop, we go to, oopsie daisy, I made a little mistake. Let me just quickly rectify that. So what I actually did was I literally created it on the desktop. I wanted a separate folder. So if I create a separate folder and I call it setup, this is what we want. So create a separate folder. My bad, made a little mistake. Now run the IDE again. And when we select the project folder, we'll select this folder that we just created, and in there all the files will be saved. So close, and if I go to file, new project, and I want to select Kotlin, click next, and project name is going to be setup. Project location is desktop, and then setup. So the mistake I made was I just put desktop. If you had put the extra folder as well, you would have created the folder for you. So that was a mistake on my part. So you can even manually create it, or just make sure you type it here. Click finish. New window. So I'll close the old one down. Not interested in that. Go to project and setup. So we have a few little files here. So what we need to do to actually create some programs in Kotlin, we need to right click src, we need to go to new, we need to go to Kotlin file class, and then we need to name it. And we're just going to name it, I'm going to call it main, but you can call it whatever you want. And we got the .kt file, which is the Kotlin file. And let me have a look at the settings, the editor. I just want to increase the font size a little bit, just so it'll be easier for you to see, just in case you're viewing your mobile. So if I change that to 48, again, this is just an optional step, so this is just more for demonstration purposes, so it's easy to see. We need to create a main function, which is the main entry point of your application. So I'm not interested in installing this at the moment. So we're just going to say fun main, and it has some arguments. So args colon array, and this is a string. I'll explain all of this in a second. And now if I just like put a print line in here, I'm gonna say hello world. So that is just our really simple application. And to run it, just go to run. And if we just click run, select main kit, and this is gonna run it. So it's just compiling it, as you can see at the moment. And there you go, it says hello world. And that's it. It's as simple as that. We've created and set, or I should say, we've set up the IDE on Linux. We've created a Kotlin project. We've just done the main little function. So fun is the keyword function. Main is the main entry point that you always need in all applications. And these arguments, or I'll just turn the code around. These arguments are passed in by the compiler. This is just a little requirement. You can modify those arguments if you want to, depending on the way you run it. But we'll cover that, separately. And these curly braces just indicate this code is part of the method, and we can put more code as well. One thing I want to mention: Kotlin does not require semicolons. I am putting it because so many languages do, like C#, C, C++, Java, JavaScript, PHP, and if the language doesn't enforce semicolons but lets you use them, I'll recommend using them, just because it just creates that mindset. So when you do switch languages, you don't miss out the semicolons, which will really annoy you when it doesn't work. So that's just the reason why I'm using semicolons in this language. That's it. Thanks for watching. If you have any questions, feel free to pop me a message, and as usual, I look forward to seeing you in the next video. Hello, in this video I'm going to show you how to run Kotlin code online. So essentially an online editor that allows you to quickly test stuff. It's not the the ultimate solution for a full-based project, but if you want to test something, this is pretty cool. Okay, and what you want to do is go to try.kotlin.org. I'll provide links to all of this. Try.kotlin.org. So it's try.kotlinlang.org, and here we have the editor. We got a default main, and if we click run, we can select what sort of compiler we're using. JVM is fine. So it's running it, and as you can see, it's printed it out here. So what you can do is do extra stuff here as well. You can have different files, you can save it. This, and there's a bunch of examples. This is a bit more, I would say, of like a offline editor but online. But if you want a more playground environment where it's literally want to try 1 or 2 lines of code, even better is if you go to kotlinlang.org, go to try online, which is the playground version. This looks nice. If you want to quickly check something, this is the way to go. So if I just click play, we have Kotlin code working. So those are the 2 ways to program in Kotlin and check stuff out directly in your browser. There's examples as well, so feel free to check them out. Really do recommend checking them out. There's a lot of stuff here that are available for you to take a look at. Thanks for watching. If you have any questions, feel free to pop me a message, and as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming tutorial, we are going to take a look at variables. So first of all, let's just quickly cover what a variable is. A variable is essentially a data container. It allows you to store a value. It could be anything you want. It could be a number, for example, like 55. It could be a string. So hello world, for example, is a string. And the benefits of variables: allows you to store the data, and not only can you use it later on in your code, you can use it multiple times. And if you change the variable, any uses of that variable afterwards also are updated with the new value. So if you need to use that value, for example, maybe something that if it changes in one place, has to change everywhere else. So maybe a calculation, you calculate your story once, and it can be used anywhere. Okay, so a variable also refers to a memory location. Basically, on your RAM stick in your computer, there'll be a low memory location, and the variable is stored there. And to create a variable, it's really simple. You use the keyword var. Now you name your variable. So for the variable name, you can put anything you want pretty much. The epic var. There are some naming conditions, and I'll provide a link to that. But for most of the time, you can do whatever you want. So equals, and let's say if I put my name, so Farhan. Semicolon. Again, semicolons are necessary in Kotlin, but they are permissible. Therefore, I'm going to use it out of good practice. Now, we could use it in some capacity. I'm just going to print it out. So if I print this out as epic var, because no quotations around it, the compiler knows this is referring to some sort of variable. As you can see, the color has changed. Now, if I just run it, let's see what we get. Okay, so we have something unresolved. I put lowercase v. So it is case sensitive. Just make sure you pay attention to that. It's good that I made that mistake so I can demonstrate it. As you can see, we've used it right here. If you want to store a number, you can do so. So if I say a num1 equals 5, I could print that out. So I could do print ln num1. And if I run it now, there we go. We've printed out the number 5. There's another way that you can create a variable, and instead of using the keyword var, you can use the keyword val. So val. So if I say num2, for example, and I assign the value of 67, let's see what happens if we print that out. Print ln num2, run that. As you can see, it printed out. Obviously, we'll get rid of the hello world for now. As you can see, it printed off my name, so the epic var, printed out num1 and num2. So at the moment, it doesn't really look different, but let me show you what happens if I were to do epic var, because you can update variables as well. So if I assign my alias, which is Batman, and I do num1 equals a different number now, let's say 100, and let's say if I do num2 equals 99, all of them have this, are fine except for this one which has a red line. Val cannot be reassigned. So val is what you would call in most other programming languages, it's a constant. Simply put, after you've declared the variable, which is on this line here, and assigned a default first value, you cannot reassign values. So that will produce an error. Look, there you go, Kotlin val cannot be reassigned. But if I comment that out and I run it, as you can see, it works fine. Obviously, doesn't print anything out. Let's print it out now. There we go, we have the updated value. Num1 has been changed, so has epic var. And yeah, that's it really for variables. A variable created with the keyword var, so var, can be modified later on. Don't have to modify it, but it can be. Val, so val, a variable created with that keyword, cannot be modified afterwards. So that's just something to bear in mind. The use cases will be val. So if you have a constant, for example, maybe pi, so pi, the mathematical constant, you might want to put, or you would want to put that in val, because that doesn't change. That's a constant, and that's going to remain the same. Whereas this could be, first name, for example, and that might change depending on the user. Okay, so that's it for variables, the basics of it. I'm going to cover data types in the next video, because as you can see, this right here, this piece of data and this one, they're different. One's a number, one's a string. So we'll cover all of that and how that sort of comes into play with variables in the data types video. If you have any questions, feel free to pop me a message. And as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming video, I am going to discuss data types. So they're going to be in relation to variables. So if you don't know what a variable is, I recommend checking that video out. Once you've done that, welcome back. Okay, so data types. We've got a few variables here, and we're using var, and val. Keyword doesn't really matter at the moment. This is a string data type. This is a number, and this is a number. What does that mean? Okay, so as you can see here, I've reassigned a value to num1 and epic var. But what happens, instead of assigning a number to num1, I assign a string like hello. What happens? It's red and it says type mismatch required int found string. So let me run it. It won't compile it because it's giving you a red line, mismatch, and the reason is, even though we haven't specified a data type, when you first assign a value to a variable, it will just become the data type of that particular value. So this is now a string variable because this is a string. This is now a number variable. This one's also a number variable because it's val. You can't actually change it afterwards anyway. So I'll get rid of val. Really, that data types don't really matter too much in the case of vals. And there's 6 main data types. There's actually, there's a few more than that. So there's number data types. Within that, you have byte, short, int, long, and those are whole numbers. And depending on which one you have, they're the specific range. So byte is from -128 to 127. It's a byte, so it's 8 bits. An integer, which is 32 bits, ranges from 2 billion or -2 billion, 147,483,648 to 2,147,483,647. A long is 64 bits, and I'm not even going to try and say the number out. It's really big. Numbers you can also do in the form of floats and double, which are decimal point numbers. Double just has higher precision. There are character data types, which is just an individual character. There's Boolean data types, so true or false. There's arrays, there's strings that we've already covered. I'll provide a link so you can see the differences in there. Once you understand what we're doing here, you'll be all good to go. Okay, so if you don't specify a particular data type, depending on what value is first assigned, it'll become that value. So this has to be a number. So this has to be 89, for example. And that's the same with this. If you try and assign something that's not a string, it will not work. The way that you specify a particular data type is if I do var, if I do num2 equals, or you just put colon, and now you specify the data type. So I'm just going to say float. So this is a decimal number. So it equals 5.5. And what's this known about? Okay, so it just needs to have f at the end of the float. That depends on the language. Sometimes it's strict like that. So if I print out println num2, and now let's run it and see what we get. Okay, so it's printed out 5.5. My thinking, what's the benefit of this? Because we've actually added more code. And if it gets the data type based on the value that's first assigned, would we not just do that? That's fine if you're going to assign a value. Maybe you don't know the value for num1, for example. As you can see, it's got a red squiggly line there. It says this variable must either have a type annotation or be initialized. What that means, it must either have a data type specified, and that way the compiler knows I need to create this type of variable, aka assign this amount of memory in the RAM, and only allow this types of values to be stored there, or initialize is the same thing as doing this, for example. Whereas if I were to get rid of the value assignment here, this is fine. Now, obviously, this is saying it must be initialized, but this line doesn't have a problem. So if I say num2 equals 8, 8.7f, for example. If you want to do a whole number, you can just do like 8.0f. And now if I run it, we get 8.0 printed out. So data types, or specifying the specific data type of a variable, is really useful if you're not going to use that variable straight away, if you're going to declare it, but assign a value later on, so you don't know the initial value. Then specifying the data type is not only useful, it's crucial. But I think it's good to specify the data type anyway, even for values that are assigned straight away. It just creates consistency, and when you're scanning the code and maybe you have thousands of lines of code, it's just easy to process and read. So that's it for data types. Like I said, there are other data types just in numbers. There's characters, strings, boolean, and obviously if I were to do like colon string, for example, that's the equivalent for string, but the format is exactly the same. I'll provide a link so you can check out all of the different types. It's simple as that. If you have any questions, feel free to pop me a message. And as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming video, we are going to look at strings. If you aren't familiar with variables or data types, I recommend checking those videos out first. If you're good to go, then let's continue. Okay, so what we're going to do is create a variable. So if I do var, and I'll call this epic string, and I'll assign it the characters hello world. Okay, simple stuff, and I can print it out. You could do more stuff with it. You could assign it to another variable. You potentially store in a database. That's totally up to you. Epic string, and if we run it, it will just print out hello world in the console. Simple stuff, nothing amazing, but what you can do with strings is, in most languages, and this includes Kotlin, is strings are generally objects where they have extra methods applied to them. So if I do epic string dot length, so this is a value, a property that is assigned, and you can guess what this does. This just returns the length of that variable, 11. My thinking, there's 5 characters in hello, 5 characters or letters in world. 5 plus 5 is 10. Where's the 11th one? The space in the middle. Spaces in computers or in ASCII, I recommend checking out ASCII if you're not familiar with it. I'll provide a link to it. Is a space is just as important or as valuable, as worthy as any other character. So it takes into consideration that as well. Another thing that you can do is use certain methods. So if I do println epic string dot get, for example, and if I get, I don't know, 7, what do you think this will return? Let's have a look. It returns O. So it returns the character that's at position 7. So if we look at it, you might thinking, okay, 1, 2, 3, 4, 5, space as well, 6, 7. So why is it printing out O? The reason is, remember, computers always start at 0. So this is 0, 1, 2, 3, 4, space is 5. W is in position 6. O is in position 7. So this is great if you want to check certain characters. Another thing you can do is a comparison. So println epic string dot compare to. So if I specify another string, this could be a string variable or just like a string like this. And if I say hello world with no space, let's see what we get. So it prints out minus 55, obviously that's not right. So if I put in space, and let's see what we get. So we get 0. If we were to do that. So that's the difference. It'll show you, the change in it. You can compare a direct string as well. Last thing I'm going to show you is the plus method. If I create a new variable and I say, actually, that's fine. Yeah, I'll create a new one. So I'll say var result equals epic string dot plus. So if I specify another string like, so if I specify my name, again this could be a variable or this could literally just be an inline string like so. And now if I were to print the result, let's see what we get. So we get hello world for Han. So the plus concatenates the strings together, which just literally joins them together. If you want a space here, you'll have to put the space either there or there. So that's how you just join strings together. There are a bunch of other methods as well for dropping, for counting, for character sequences. I'll provide a link so you can check them all out. But once you've learned all the principles that I've shown you in this video, you're all good to go. So that's it. If you have any questions, feel free to pop me a message. And as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming video, I am going to show you arrays. So arrays are a collection of similar data types, for example, strings, integers, etc. And they're pretty much the same as they are in most other programming languages. And I also recommend checking out the variables video and the data type video before you have a look at this. Okay, so if we create a regular variable var I, for example, and I'll assign a value of 8, and I can obviously print this out. So print ln, and it prints out 8. Okay, that's all well and good. But imagine if we have loads of values and they're all sort of linked. Maybe they're a set of high scores, 5 high scores, for example. So instead of saying, var score 1, var score 2, what we could do is create a variable called scores, for example. Say equals, and then do array of, and we could specify 5 values, for example. So if I say 1, 3, 5, 78, and 3. Okay, so if we want to print it out, we do print ln. If we put scores in like so, let's see what we get. So as you can see, it doesn't quite get it. So this basically just gets a reference to the memory location. To get an individual value, if you put square brackets, put the index. So if we put 0, this will get the first value. Remember, computers start at 0. So it gets 0, or it gets 1. If I say 1, it should get the second index, which is this one right here. And so you'll get the value 3. Okay, so it printed out that value. You can do the same for pretty much any type of data type. If you are using a specific data type or you want to mention a specific data type, the way you would do it. So if I do the var names, for example, equals array of, and maybe we want to assign names. So I want to say Bob, Batman, Farhan, pizza, and I'll say mashed potato. So some epic names. And if we not only print out the score, we print out the names as well, like so. Let's see what we get. So Batman has a score of 3. You can specify the data type just so it's made clearer. Like so, you put angle brackets, you can specify for a number, for a string, whatever it is. You can use other methods for integer arrays, also int array of, that is specific to integers there. But I'm happy with the array of method. I think that's really all you need. So I've shown you how to actually get specific values like so. There are some other ways of getting a value. So for example, if I copy this, so instead of doing square brackets, which is a common way in most languages, you can do dot get, and then if I say 1, dot get, and I run it, as you can see, it's printed out the same. So this right here, using a method and specifying the index compared to using square brackets, produces the same result. So just depending on which one you prefer, if you come from another language, you'll probably prefer this one because this will seem, familiar. If you're not coming from another language, this is a bit more obvious because there's a function and there's a particular word there. And if you want to set a value, similar principle. You could do, let's say scores. I'll stick with, the index 1. So if I say 1 equals 8, and I'll do print ln scores 1. Run that, see what we get. So as you can see, it's printed out 8 once it's been modified. So that other 8 is coming from here, so we can get rid of that. We'll get rid of this one. That's useless to us now. Okay, so another way to set a variable is to do scores dot set, and first of all you need to specify the index, so 1. Now specify the value, let's say 67, and we could print it out however we want. We could use the .get method, we could just use square brackets. I use square brackets because that's what I was first doing in programming languages like C++, which was the second language I ever learned. And if I run it now, as you can see, it's got the value 67 assigned to it at this point. So to set values to an array for a specific index, you can use any one of these methods. For getting, you can use any one of these methods. And this is how you create an array of sort of common values. They have to be the same data type. That's just something to bear in mind. What you can also do, if you don't have the values, specifically, you could just create an array of a certain size. So that way the compiler knows it's of size 5 or 10, and it reserves that much memory. That's the only reason the compiler needs to know that it's of size 10. So it says, if each value is a byte, so it's 8 bits, and it's just the arrays of size 5. 8 times 5 is 40, so it needs to reserve 40 bits in memory. That's the only reason it needs to know, nothing more than that. But you can specify the size from the start, so therefore you don't have to assign the value. I'm going to provide a link to more information about arrays, which includes creating an empty array but with a specific size, and I want you to experiment with that. If you have any questions, feel free to pop me a message, and as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming video, I am going to show you the process of type conversion. So I recommend checking out the data type video first. If you haven't done so, feel free to take a look at that. If you already know what data types are, fantastic, let's get going. If I create a variable and I call it I, for example, I assign a value of 9, simple stuff, that's fine. If let's say I create another variable and I'll call it X, the name of the variable doesn't matter, but I'm going to set the specific type, and I'm going to do this. So I'm going to set it to a long, and I'm going to assign it to I. So we're getting a red error. So if we run it, let's see what the error is. It says type mismatch, inferred type is int, but long was expected. And if you know about data types and you've done your research about them, then this is an integer. And long is, just an integer, but long A can just store a larger or a smaller number if you're going into the negatives. So 9 can be stored in a long. In some programming languages, it'll do the data type conversion automatically for all sorts of data types. Most languages don't do it that way. The other way they do it is if the data is very similar, so a long and an integer, it'll be like, okay, they're both numbers, they're both whole numbers, it's easy, easy stuff, and you'll be able to do the assignment. Still, conversion going on, but the compiler handles it. Kotlin, unfortunately, doesn't do any of that. So in a way, it's good because it actually instills in you the actual mindset of data type conversion, but it can be annoying for first time programmers that are coming to Kotlin as well. Okay, so if we want to convert so let me show you. If I were to do, if I created another variable, say called var y, and I did int equals I think that is fine. This line has no problem because both of these are integers. If I were to, let's say that this is a long, now this line has a problem because it requires an int. We found a long, whereas this line, it's okay. But let's just change it back or remove this line. And what we can do is on the actual variable itself, if we do dot to, we can convert it to a different data type. So if I say dot to, what was it, long? There we go. And if we do print line now, so print line x, this is compiling, as you can see, it's printed out 9. So that's data type conversion. We can go into, other sort of conversion as well. As you can see, we could do on x, for example, x dot to, we can convert it to a byte, to a character, to a double, float, integer, long, short, to a string. The string one's pretty interesting. So if, let's say, I create a variable, let's say epic string, and this has a data type of string, and we're going to assign the data afterwards. Maybe I want to assign a number to it. So if I do epic string equals x, it gives me an error. So as you can, as you expected, it says required string and it gets a long. So if you want to put a number in a string, you just do dot to string, and now if we print out epic string, there you go, it's printed here. The only difference this time is epic string is, well, a string. As you can see the data type right there, and this allows you to convert a number to a string. Obviously, if you try and do some mathematical calculations on this variable called epic string, they won't work because this isn't a number anymore, it's a string in terms of the computer. The mathematical calculations would need to be done on a variable such as I or x that is in the number format, in some sort of number data type, and then if you need to store it into a string variable, you can do. So that's data type conversion. You can do a bunch of other stuff, but honestly, if you just do dot to, you'll see all the methods, pretty self-explanatory, and you can even convert from string to a number. I want you to have a go at that. If you have any questions, feel free to pop me a message and I will help you out. And as usual, I look forward to seeing you in the next video. Hello, in this video I am going to show you how to comment your code in the Kotlin programming language. Comments are essentially pieces of code that doesn't get compiled. And my thinking, if it's not getting compiled and actually using the application, what's the purpose of it? To document the actual code itself. And it helps not only yourself when you look at it, 6 months later or even a week later, know exactly what's happening, especially when it's some sort of complex algorithm that you've created. And it helps, your team as well, because, in a bigger company, it's not just me, one of you working on a project, it could be 10, it could be 100 plus coders. If it's an open source project, it could be tens of thousands of people contributing. So having, a few comments helps sort of document it and, provide your thought process. And it's good to comment as you go along. 1, it's fresh, and 2, because commenting is unnecessary in terms of the running of the code and it's tedious, if you leave it to the end, you will not do it. Trust me, you will not do it. So whether you're in education or in a professional environment, I recommend commenting as you go along. I'm not saying, write, 5 characters, of a line or just one line, just commenting straight away. But, every few lines, if you've done something new, like a new, snippet that performs some functionality, then comment it. Commenting is really easy. You just put 2 forward slashes, and if I say hello world, and see what this is saying, we can replace with block comment. No, don't want to do that. That is fine. I'm going to actually show you that in a bit. As you can see, this hasn't done anything, and it's not meant to. If I get rid of this, it will give us a compilation error because that's not valid code. Whereas this actually gets removed at the compilation stage, so this doesn't even make it into the final executable when you run it. This is just for our purposes. If you need to comment multiple lines, or you have you're trying to do some sort of description, can't really fit on one line, you can do a multi-line comment, and you start that with / asterisk, and then you end it with, it's automatically ended it when I click enter, but so it's asterisk / so any code or any lines between this after manual appear are comments, and they will not get run in your application. Okay, so before we wrap this video up, there's one other use case that I want to show you for comments. Another great thing is called commenting out code. You can do this with a single line or a multi-line comment, and what that is maybe I want to see what the application runs like if I didn't do this. Instead of essentially doing this, deleting it, because I'm not certain that I want to delete it, you could just do this, comment it out, and that way it actually doesn't get deleted, but it doesn't get used in the final application. And as you can see, this has incurred an error which says variable epic string must be initialized. So it's allowed me to check what it does or what would happen if the code technically wasn't there without actually removing it. And I can just bring it back. So that's great. Instead of constantly just removing and adding code, if you got something there, I'm going to test what it's like without it. Commenting it is a good way to go. And if, let's say, I wanted to comment these 3 lines out and see what would happen, instead of doing this, as that's a bit tedious, and imagine if you have like 50 lines of code, you could just do this, and that's it. That's a multi-line comment out. That's a comment code out using a multi-line block, and that is it. That is comments. If you have any questions, feel free to pop me a message, and as usual, I look forward to seeing you in the next video. Hello, in this video I'm going to cover arithmetic operators in the Kotlin programming language. So operators essentially allow you to perform some operation on values and variables. The arithmetic operators allow you to perform, I think you've guessed it, arithmetic operations. So you've got addition, your subtraction, multiplication, division, and the modulus. I'm going to cover all 5 of them. So first of all, let's create a couple of variables. So var, say num1 equals, let's put 55. The numbers don't really matter. Let's say num2 equals 23. And we are going to say print ln. So this is going to be addition operator. And to add 2 values or 2 variables together, you just put plus, as you would write it on paper. So num1 plus num2, and that result is returned to the location that it is actually written in. So this right here is the equivalent of writing 78. But let me just show you that that's what it prints out. There we go, it prints out 78. Now let's have a look at the subtraction operator. If you already have an idea of what to do, you've already figured it out, I recommend pausing the video, having a go yourself, and then just having a look to confirm. So it's a great way of learning. If not, feel free to keep watching. So if you just do num1 minus num2, and if we click run, we should get, we get result 32, which is right. 55 minus 23 is 32. Now let's have a look at the multiplication operator. Multiplication operator. So these are all, I'll do a multi-line comment. I'll say so these are arithmetic operators. And even what I'll even do, put a bunch of dashes. You know, this is just for styling, no other purpose to it. So arithmetic operators, the multiplication operator for the print line, and I'll do num1 times num2, and if I run it, we'll get 55 times by 23. Let's see if I can work it out in my head. 55 times by 20 is 1100. Let's just keep that at the side. 55 times by 3 is 165. 1100 add 165 is what? 1265. That's what I'm saying. I'm saying 1265. Okay, there we go. I've shown that my mental math is pretty decent. Thank you very much. I'm only joking. So the multiplication operator, that's it. It's the asterisk symbol, whereas the plus and minus resembles the exact same way you'd write it on paper. Multiplication and division is slightly different, simply because the only thing that represents, or the closest thing to the multiplication operator on a keyboard is the letter X, and that's, well, the letter X. That's reserved for that functionality. And the next operator I'll show you is the division operator. And if I put println num1 divided by num2, and this is another one. Division, instead of it being like the what is it, like the dot and then the horizontal line and then the dot again, it is just a /. And let's see what we get. So we get 2. You might be thinking, okay, everything else seems fine, but why is this giving us 2? 55 divided by 23, 2 times 23 is 46, 3 times 23 is 69. So it's not quite 3, it's not 2, it should be like 2.5 almost. And the thing is, because these are integers, and the way we are writing it like this, it's doing integer divided by another integer. As a result, it's only going to return an integer, and it just gets rid of the decimal point. If we want to do, let's say, full accurate division, we do num1 dot 2, and if we convert it to, let's say, a float, if you don't know what we're doing here, recommend checking out the data type conversion video. We do the same for num2 dot 2 float, and now if we run it, let's see what we get. As you can see, we get 2.39, etc., etc. So this is a way if you want more accurate numbers, and it really comes into play when you're doing division. The last operator I'm going to show you is the modulus operator, and this is a simple one. So this is println num1. To do the modulus operator, you put the % symbol, num2. Let's see what we get. We get 9. I'm thinking, okay, what the hell has even happened? If you don't know what the modulus operator is, it's essentially does division, integer division, and it gives you the remainder. So remember long division that you did at school. So you do how many times is 23 going to 55? Count it up, 23, 46. You can't go over more than that because it goes over number 1. So it goes into it twice, but what's the remainder? It's 55 minus 46, which is 9. And that's what the modulus operator does. If you want to work out the remainder of dividing two numbers, that's what you do. That's it, simple stuff. It's the same if you have, instead of, integers, longs, doubles, shorts, bytes, whatever number you have, or floats, or whatever, it's the same principle. Thanks for watching. If you have any questions, feel free to pop me a message, and as usual, I look forward to seeing you in the next video. Hello, in this programming video, I'm going to show you how to do relational operators in the Kotlin programming language. So relational operators allow you to compare two values, two variables together. And the most basic one is checking if one value or variable is equal to another. And to do that, so if you say equal to, and if I do print ln, and if I do num1, so I've recreated two numbers here, 55 and 23, two variables. Double equals, so that's the sign. If you do single equals is the assignment operator. Double equals is the comparison operator. Equal is checking if the left side is the same as the right side. If I do num2, let's see what happens when I run that. What result do you think we're going to get? We get false, and that's right. It's wrong. If I just change this to 55, I think you can guess what the result's going to be. It is going to be true. And at the moment, it's not much use for you. Just bear with me. Later in this series, we're going to look at loops and conditional statements, such as if statements. And that's where it's going to come into play. Being able to see if, let's say, a certain condition is met, as a result, to perform a specific, functionality. So that's the equal to operator. You can have another one called not equal to. If you can guess what this does, this will return true if the left value is not equal to the right value, but it will return false if they are the same. And then if I do print ln num1, and to do the not equals, instead of doing double equals, you put exclamation mark equal. So not equal to num2. If I run this, we should get false for equals. False for equal to, but not equal to will yield true because they're not the same. They are 55 and 23. Now I'm going to show you the greater than and less than operators, and I'll show you both of them right now at the same time. And the greater than, they will, all these operators always yield true or false values, and based on that result, you could do something. You could assign it to another variable, like a result variable, and then use that in a conditional statement, and as a result, run some, piece of code. And so if I do num1 greater than num2, so this is the greater than variable, operator. This is the less than operator, and that is the angle bracket the other way. The way I always like to remember it is the open side is the bigger side, or that's meant to be the bigger side. So this is saying the open side is bigger than the closed side. On this, the open side is bigger than the closed side, or the greater than, the left side is greater than the right, less than, the left side is less than the right. So if we run this, see what we get. Okay, so we get true and false. So is 55 greater than 23? Yes, so that's true. Is 55 less than 23? No, it's false. What happens if I do this? 55. So they're both the same number now. What do you think we're going to get just for greater than and less than? We get false. That's because this is just saying, is it greater than? And this is just saying, is it less than? It's not, checking if it's greater than or equal to, or less than or equal to. And we can do that as well. That's really simple. If I copy these, greater than or equal to, greater than or equal to, and to do the greater than or equal to, or the less than or equal to, all you have to do is do the symbol plus an equals on the right side, symbol plus the equals. So this is saying, is num1 greater than, or is it the same as num2? If any of those two conditions are met, then it will result in true. So let's have a look at this. Both of them result in true, and that is because, is num1 greater than num2? No, 55 is the same as num2, but because this operator is greater than or equal to, it is equal to it, so it returns true, and the same principle applies for this right here. So this is great for checking values. Maybe you're checking what your user has input, and it's meant to be within a certain range. You can use these basic relational operators to be able to check values that your user has given you and make sure it's correct. It's a valid number. That's it, simple stuff. That's the relational operator. If you have any questions, feel free to pop me a message. And as usual, I look forward to seeing you in the next video. Hello, in this programming video, I am going to show you the assignment operator in the Kotlin programming language. Okay, so if we have, what I'll do is I'll get rid of this right here. I will just have the one variable 55, that is fine. And this right here is one of the assignment operators. This is the basic assignment operator. This right here, this equals, single equals, this is saying whatever's on the right hand side, whether it's a value or a variable, get its specific value and assign it to the variable on the left. So 55 goes into the area of memory where num1 is positioned. So num1 now has the value 55. So that's the basic assignment operator. That's it. Quick video, really over and done with. Nah, I'm only joking. There are 5 other operators that I want to cover as well. Before we get onto them, I would recommend checking out the arithmetic operator video, because it is essentially the arithmetic operators combined with the assignment operator. If you've checked that out, fantastic. If not, I'll be waiting right here while you have a look at that. Okay, all good to go. Now let's take a look at the assignment operator. The first one is the addition assignment operator. And if we do num1, for example, and we do plus equals 5, what this is essentially the equivalent of is saying num1 equals itself plus 5. So it's saying get itself, add 5 to it, and assign that back to that specific variable. So num1 is now 60. So if we run it, see what we get, we should be getting 60. And you could run this as many times as you want. You just keep adding 5 to it, and you could change the number 10. It could be a minus number. It could be a decimal number. It doesn't matter. Okay, so what I'm going to do is assign num1 back equals 55 again. The only reason I'm, what's this saying? Yeah, that's fine. The reason I'm changing it back is it'll get sort of confusing to track what the number is, because it's going to keep using the same variable. The next operator, and I'm sure if you've watched the arithmetic operator video, you should get to guess not only what it is, how we actually use it, is the subtraction assignment operator, and it's minus equals. So this just takes away 5 from the current number. It's the equivalent of writing this, and this is valid code. You could write it in this format if you want. And now if we run it, num1 is 55, then it gets taken down to 50. So that's the subtraction assignment operator. Let me show you the multiplication assignment operator. So multiplication assignment operator, you just replace the minus with a times. It's the same thing as saying num1 equals itself times by 5. And now if we run it, 55 times by 5 is 275, and that should be the result of the last print line, 275. So that's the multiplication assignment operator. Like I say, you could do this multiple times. So if I did it again before the print line, it does 55 times by 5, which is 275, and that gets assigned to num1. Then it does num1 times by 5 again and reassigns it to itself, which is 275 times by 5, which is what, 200 times by 5 is 1000, 70 times by 5 is 350, 5 times by 5 is 25, so it's what, 1375 the last one will be. There we go, fantastic stuff. I'll get rid of this, but you can do it as many times as you want. You can mix and match these as well. As an extra task, I recommend doing that, mixing and matching them, and see how that goes. The next one I want to show you is I think you can already guess, is the division assignment operator. And it just divides the current number and reassigns it back to itself by whatever's on the right hand side. So it's the same thing as doing like so, and this will get us 11. 55 divided by 5 is 11. And now the last one I'm going to show you is the modulus assignment operator. The modulus assignment operator. And this should yield a result of 0. If you don't know what the modulus assignment is, I do explain it in more depth in the arithmetic operator video, but it's basically just finding the remainder after you've done division. But 55 divided by 5, just gives you 11. It goes into it a whole number of times. Therefore, the modulus of it is just 0. Whereas if we change this to 57, 5 goes into 57 11 times with a remainder of 2. So if we run it now, it will give us an answer of 2. There we go. Those are the assignment operators, including the most basic one that we've already done several times, all the way to the arithmetic operators combined with the assignment operator. Pretty simple stuff, but if you have any questions, feel free to pop me a message. And as usual, I look forward to seeing you in the next video. Hello, in this programming video, I am going to show you the unary operators, and they use with just a single, variable, single value, and they're for performing just like a small functionality, but it simplifies a slightly longer piece of, line of code. The first one I want to show you is unary plus, and if I do, I've already got a variable called num1, and it's got a value of 55. So this is the unary plus. We'll do println. We'll do println, and if you just do plus before it, it performs unary plus. Just yields 55. If I make it minus, you'll see what it gets. Still produces the same. So if you need the unary plus for a specific functionality, this is the way to go. The unary minus, you'll see a bit more obvious what it does. So if I do unary minus, if I do println minus num1 minus 55, it basically just flips the sign. So it goes from plus to minus or minus to plus. The next one is incrementing. So I'll say, so there's a few different ones. There's pre-increment, there is post-increment. There's only a couple of different ones. I said a few, I've done a couple. And if I do println, and I'll do num1, and to do the increment, you do double plus. So this is the same thing as this. This is a shorthand for saying num1 equals itself plus 1. It's just adding 1 to it. Or it's a shorthand for saying num1 plus equals 1. That's an even more of a shorthand, that is. And if I run this now, let's see what we get. So you got 56. It's added 1 to it. Okay, that's simple enough. What happens if I do println and I do num1, but I put the plus at the end? Still technically the equivalent of this. So if it's added 1 to it here, which is now 56, this should be 57 now. Let's see what we get. It's still 56. We've got a little warning. I'll explain that warning in a second. And if I were to print it out again, but without any operator on there, we should, what do you think, just get 56? Because that's what this line yielded. It gives us 57. So the difference between putting the increment or the decrement operator, which I'll show you in a second, the decrement operator, putting it before or after the variable, and this is the same in all programming languages, is this. If it's before, this piece of code is executed and finished before the rest of the line, before this. So this has already executed, it's already added one to it, and that's what print line uses. Whereas if you do it afterwards, what this is saying is do the print line or whatever that piece of code is. Only then, once you've done that, do the increment. So it does the increment just after the print line, hence why in here we get the value that we expected. And behind the scenes, this is essentially what it's doing. Okay, so there's also the pre and post decrement. They're pretty simple. So pre-decrement, post-decrement, it's just two minuses, before or after, and it's the equivalent of this. If I run it, so if it's 57 here, it'll give us 56 here. It'll give us 56 again here, because this is a post-decrement, and this is only, only one gets taken away from it after this line is executed, but this will give us 55 again. There you go, we have 55. The last unary operator is the not operator. So the var, epic value equals true. And if we want to reverse a Boolean variable, for example, we just do print line, you put the not symbol in the variable itself, so epic value, or just a Boolean value, and you just reverse it. This will print out false now. And if this was false, this will reverse it from false to true. So it will now print out true. That's it. That's the unary operators. If you have any questions, feel free to pop me a message. And as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming video, I am going to show you bitwise operators. So I've got a variable right here, got the value, it should be 84, not negative 84. Got 84 assigned to it, and I've got it written out here in comments what the binary equivalent is. So bitwise operators allow you to change the value on a binary level. So the first operator is shift left. And this just shifts all the binary digits to the left by a certain amount of spaces. You can specify that. So if I do print line, do x.shl, so that's shift left. And if I say 1, this will just shift it all to the left. And so that just means it becomes like this. Sort out the formatting. And this one is obviously just 0 as well. So we should get 128 plus 32, which is 160, plus 8, which is 168. Okay, and I think you can guess we can do a shift to the right as well. So shift right. That's just SHR. Again, you can choose how many jumps you want to do. I'll copy this. Paste it here. This needs to jump like so. And 32 plus 8 plus 2 is 42. So a shift to the right will make the number 42. Next, we are going to look at the bitwise and or and XOR operators. So for that, I'm going to create two variables. So var num1 equals 78, for example. Var num2 equals 118. It doesn't really matter what the numbers are. They can be as small or as large as you want. And I'm going to do println. Okay, so the next one is I'll comment it. Bitwise or, and if I do println, I'll do num1 dot or num2, and let's run this and see what we get. So we get a value of 126, and you might be thinking, now how is this getting it? If you add them up, you get 196. If you take them away, you're not getting, you get like negative 40. Like, how are they even doing it? the addition's on a binary level. So if I'll just copy this out. So this is going to be the number 28. I mean, this one is, sorry. So I just need to, figure out what it is in binary. So 1, the 0 there, there's a 1 here, there's a 1 here. That's it really. 64 plus 8 is 72. 76, 78. Okay, so we've got 78 in binary. Let's get 118 in binary now. So 1, that's 96. That's like 112. Not that. So I think that's it for 118. So 2, 6, 22, 54, 118. Yeah. Okay, so when you do the AND operator, I will just put a bunch of these just for formatting. So when you do the bitwise operator, I mean actually I wanted to do the AND operator first. I'll do the AND operator first. So the bitwise AND, it just goes through it and it just checks if both bits are on or not. And so here is 0 and 0, that's 0, both bits are not on. Are both bits on here, 1 and 1? Yes. Only one bit's on here, so this will result in 0. This will result in 0. This will result in 0. This will result in 1. This will result in 1. This will result in 0. So this total answer is 64 plus 4 plus 2, which is 70. And the 126 will for the OR operator. So if I run it again, we should get 70. There we go. The OR operator is the same process. So if I say bitwise OR, but instead only one of them needs to be on. So this is still 0. Both of them are on, that's fine. So 1, but this will change to a 1. This will change to a 1. This will change to a 1. This will remain as 1. This will be 0 because none of them are on. Only one of them needs to be on with OR. So if I say OR, this should be, it's done. So it's 64 plus 32 is 96, plus 16 is 112, plus 8 is 120, plus 4 plus 2 is 126. So if I run it, we should get 126. Okay, almost there. Just 2 more bitwise operators I want to show you. The next is the bitwise XOR, which is exclusive OR. So exclusive OR, and it's just XOR here. And what that means is only one of the bits can be on. If both bits are on, it'll return false. If both bits are off, it'll return false. If the first bit is on, second bit is off, it'll return true. The first bit is off and the second bit is on, it'll return true. So 0 and 0, still 0. 1 and 1, you can't have both of them on, so you have to be 0 there. This is obviously also 0. This will return 1 because only one of them is on, same for this. Whereas this will just return 0. So let's add it up. 32 plus 16 is 48, plus 8 is 56, and that's it. That's our number if we do an XOR operation. And the final one I want to show you is the bitwise inverse. And I think you can guess what this does. It literally just inverses the bits. And what you don't actually do it along any other sort of calculation. So if we just do it for num1, where there's a 0, you get a 1. Where there's a 1, you get a 0. So 1, 1. So 0 here. 0 here. 0 here. We'll have 1. So let's add it up. It should literally just be 255 minus 78, which what gives you 255 take away 70 is 185. Take away 185. Take away 8 is 177. So let's calculate if that's right. 128 plus 32 is 160. 176. 177. Yes. There we go. And the method for this is just INV, but you don't pass any parameters, it just flips the bits. That's all it does, no matter how small or large the number is, and it has flipped them. So flipped it to negative 179. Oh yeah, it's inverse the sign bit as well, so that's just something to bear in mind. That's the bit, so you wouldn't technically need this. Let me get rid of that because it's flipped the sign bit. And if we just go over again, so we've got the bitwise XOR, OR, and we've got the shifting of the bits as well. All good stuff. This has been a long video, so if you have any questions, feel free to pop me a message. And as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming video, we are going to look at logical operators. These are generally used in conjunction with relational operators, so I recommend checking out that video. Once you're happy that you know about relational operators, we can, well, begin on logical operators. So there are three main operators, and the first operator is the AND operator, and the way you write it is double ampersand. And if I do print line and I do, let's say, is num1 greater than num2, which will print out the value true, because 55 is greater than 45. That's true. But if we essentially want to check multiple conditions, and only if all conditions are valid or if all conditions are true, only then would it produce a result of true, what we can do is put double ampersand and then put another condition. Maybe I say num1 is and let's say num1 is not equal to 55, for example. So num1 has to be larger than num2, but it cannot be 55. This will produce false because it is 55. If I were to change this to, let's say, 50, 50 is still greater than 45, so num1 is still greater than num2, but num1 is not 55. Therefore, all of this, this executes as true, this executes as true, therefore is true and true. Yes, it is. And if we run it, you'll see that we get a result of true. And the next one is the OR operator. So OR, and this is just two vertical lines, and you just put the two vertical lines here. This just means one of those conditions need to be true, the left or the right one. So if I change this back to 55, let's see what we get. And let's wait for it to compile. We get a result of true. Num1 is greater than num2. 55 is greater than 45. But num1 is not, num1 is equal to 55. Therefore, this produces false. But with the OR, only one of the conditions, the relational operator results, needs to be true. So if it's like an either or situation, this double vertical pipe is the way to go. Next, the last one is essentially the NOT operator. I'll write operator here. The NOT operator, and that just basically inverses the result of something. So if I created a variable here, var flag variable equals true, and I do not variable, this will just reverse that result to false, as you'll see. There we go. And if this was false, you'll reverse it to true. Likewise, if we were to put this in here instead, what do you think we're going to get? We get a result of false because this evaluates as true, this evaluates as false. This two vertical lines is saying either one of the sides can be true. This side is true. Therefore, all of this evaluates to true. But because we're not in it here, we are reversing it, it becomes false. And that's it. Those are the main, these are the logical operators that you'll need in your Kotlin programming career. If you have any questions though, feel free to pop me a message. And as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming video, I am going to cover input and output. We've already done output before. It's this, print line, outputs to the console. So if I write hello, for example, and I just click run, you know what we're going to get. We're going to get, hello. And if I duplicate it, let's say 3 instances of it, I think you can guess what we're going to get. 3 lines of hello, hello, and hello. But there's another way of doing it. There's a way where if I say print, not print line or print hello, just print, and I write, I'm going to say world in here. Let's see what we get. So you might think, okay, this is literally the same. The result is the same. And if I put it before, let's see what we get. But as you can see, the result's slightly different now. So print line says, don't print out anything else on this same line at the end. So as soon as it hits the last character, which is O, it will add a new line character and go to the next line. Whereas the print doesn't have any, concept of new lines. So this will start from here. And if I were to do, this, you'd literally get 3 instances of world on one line, the first line. So that's, the difference between print and print line. How can we get input from the user? Luckily, it's not very difficult at all. What we can do is do var. So we create a variable because we want to put it somewhere. So let's just say I'll call it data. And I'll say equals read line, and that is it. And I'll do print ln, and I print data out. So I run it. Let's see what we get. So it's sort of just paused here because it's still waiting for some input. So if I say flop on, click enter, as you can see, it's got that and it's put it here. What if we wanted to maybe multiply it by 2? So we wanted to multiply, like a number. The problem with that is we have to get the integer value of it. And to do that, we would make sure this is set to some sort of number like an integer. And for this, we need to convert it. So we do integer. This is assuming that you're actually getting a number input, not some random set of characters. The value of like so. So if you want only the number value of what you're inputting, so if I input 78, double that will be 156. There we go. So that's how the different ways of outputting to the console and inputting, getting input from the console. If you have any questions, feel free to pop me a message. And as usual, I look forward to seeing you in the next video. Hello, in this programming video, we are going to look at the conditional if statement. So the if statement allows us to check for some condition and based on that condition, run a piece of code. So if I create a couple of numbers, so var num1 equals 67, for example. Now var num2 equals, actually 1 is fine. 1 will get the job done. And there we go. I've deleted too many stuff. To do an if statement, you just do if. You put your condition inside, and this will use the relational operators and potentially logical operators as well that I'll cover in a separate video. Recommend checking them out. So num1. So if num1 is, let's say, equal to 100, curly braces, if it's equal to 100, it'll run whatever code is in here. So if I do print line, and I'll say it is equal to 100, what do you think we're going to get? We get nothing because it isn't equal to 100. So let's say change that to 67. We know the number is equal to 67. Let's say it is equal to 100, even though it should be 67. Okay, so that's pretty simple stuff. Again, in here you can have any relation operators. You can mix and match them with logical operators that I've already covered. But if you want to check for multiple conditions, so like afterwards, so if this returns false, maybe you want to check for something else. So else if, you do else if, and now the same thing. So let's say if num1 is equal to 50, it is equal to 50. And you can have as many of these else ifs as you want. So num1, let's say equal to 9. And if I run that now, let's see what we get. So I just say it is equal, it should be it is equal to 67. If I were to change this to 9, for example, what it does, or I'll show you the result and then I'll explain it. It gives us 9, or it is equal to 9. So it says, does num1 equal 67? No, this returns false. Does num1 equal 50? No. So it does it sequentially in a linear order. Then it says, does num1 equal 9? Yes. So it runs whatever code is in between the curly braces. Only one of these at any given time can, equate to true, unless the conditions are the same, which there's no reason why you would have multiple branches. If you want a default, so if all conditions fail, run this code, so some sort of fallback, you can do that by putting else, curly braces. Because there's no condition, you don't put the brackets. And in here, just do whatever code you want. I'm just doing one line of code. You can do whatever you want. You could go crazy. And say default statement. So if I run that, we get it is still equal to 9. But if I change this to 90, for example, so we aren't checking for 90, it will just default to the default else statement. Okay, so there's one other thing I want to show you, and it is this. In Kotlin, there's another unique way of using if statements. So if I create a variable, for example, and I call it result, we can assign it to the if statement if the if statement return something. So if I were to, I'm actually going to comment out this. We don't just get multiple printouts, and I'm also going to print out result as well. And the last statement in each sort of branch is the result that is returned and assigned to this variable. So if I put a string here, I'll say 67, and maybe I'll do the same here, and I'll say 50. So the last statement is the return value. It doesn't have to be a string, it could be a number, that's fine as well. I'll say default, and let's see what we get. So it says default statement default, because this is the last statement in this branch that it went into, and that is what's returned to this right here. So this is a pretty unique way of doing things. This is unique to Kotlin. I don't know any other programming languages that's done it. It might be, in other languages, but generally speaking, this is pretty unique. It's pretty cool as well. If you have any questions, feel free to pop me a message. And as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming language, I am going to show you the when statement. The when statement is essentially the same as switch statements that you see in most other programming languages. So if you know what a switch statement is, you'll feel right at home. If not, don't worry, I'm going to cover all of the different features of when. So first of all, I'm just going to create a variable. I'll call it x equals, I'll find a value of 78, for example. So if you need, sort of a specific use case for, let's say, an if statement where you have a variable and you're constantly just checking if that variable is equal to something or is in some sort of range, and you don't need the, the extra relational operators or the logical operators, you're just doing, basic equal check, the when statement is the way to go. So if I put when, put open and close brackets, and here you put the variable that you're checking, so x, and put curly braces, and now you put the value that you're checking, against. So if I put 10, and you put arrow, and now you put the code that is executed as a result of this. So if I do println, and I'm going to say, I'm just going to print out 10. And that's it. You just keep adding these. So, I'll put that 50. So 20, 30, 40, and 50. And as you can see, it's essentially like an if statement, but a very simple version of it if you're just doing a quick comparison. So it's prints out 50. Okay, so that is pretty darn cool. You can, if you want to have multiple lines of code, for let's say one of these branches, so maybe for 50, what you do is put open and close curly braces, and you put all your code within those curly braces. And now I could put another, let's say, print line, for example. I'll say everything is awesome. And now if I run it, we will get the result of 50, and everything is awesome. So if you want multiple statements, you can use, brackets. There's another thing that you can do is, for example, maybe 10, 20, and 30 will result in the same code being executed. And in this case, I'm just going to do a print line. You can combine it with these curly braces for multiple statements. So if I just say epic, so epic, and if I change this to 10 and I run it, we'll get a result of epic. If I change this to 20, we'll still get a result of epic. It's technically a different line of code, but if we want to execute the same line, we could simplify it by, essentially doing this. We could say comma 20, comma 30, and now if we get rid of that, anything when x is equal to 10, 20, or 30, you'll execute whatever code is after this little arrow right here. And the other way that you can do it is, within a range. So if we say if it's within the range of 40 to 49, you just put dot dot, put the final number. But the difference here is at the start you have to put in. So if it's in this range, then you'll print out 40 to 49. So if I say 40 and I run it, we get 40 to 49. If I say 45, we get 40 to 49. So that's how you do it if you want to do multiple comparison, but they execute the same code. If it's within a certain range, instead of listing them all out, you can do it like this. And this is how you do a multi-line statement. The only last thing I want to show you is doing it as an expression. So it'll return a value and that will get assigned to a variable. So if I copy this and I'll comment this out, what we can do, same way that we did with if statements, we can do var, let's say epic var equals this. Yeah, we need to provide a final statement, so we need to do an else just in case it's unable to get anything. So we could return this value and we'll say default. And we need, values for everything else as well. So I'll just say, instead of doing all these lines, I'll just say it is I can put some colon there. I'll say 10, 20, or 30, and I'll do something similar here. I'll comment 40 to 49. And for this one, we'll just say 50. So this last value is what is returned, and it's returned to epic var. So if I print epic var now, and if I run it, after everything else, we get 4249 because this value is returned back to epic var, and that is what's printed out. So that's the when expression, essentially like the switch statement in most other programming languages. If you have any questions, because we covered quite a lot, feel free to pop me a message. And as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming video, we are going to look at the for loop. So the for loop essentially allows us to, iterate over, maybe an array or run a piece of code X amount of times. So it's really cool. So if we create an array, so var, I'll call it epic array equals array of, and if I put numbers here, 1, 2, 3, 4, 5, 6, doesn't matter what the numbers are or what the values are. Instead of trying to print them all out like this, doing epic array 0, as you can see, this is very tedious, and we don't even have that many values. Imagine if we had 100 values, 1,000 values. It's very tedious. What we can do instead of this is put a for loop, and we can say for each item in epic array, and it's a loop over it. So if we do print line item, we can print them, we can do whatever we want with them. As you can see, we've got each item with just 4 lines of code, and if I add more values, so if I add 7 and 8, notice the for loop I'm not even changing, but the code still gets all of the items in that array. So that iterates through all of the array. And something else you can do, and that is essentially iterating through a range that you specify, or you mean us. So if I say for, and you have to specify some sort of variable name, so let's say I. This is very common in loops and in coding in general. So it's for I in 1 to do dot dot dot, I'm going to spell incorrectly, dot 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 1 dot 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 15, for example. And now I will go from 1, 2, 3, 4 all the way to 15. So if I print line I, let's see, prints out 1. Obviously we'll get rid of the comment this line just so it doesn't disturb this right here. As you can see, it prints out 1 to 15. We could do a mathematical calculation, so timesing it by 10 or times it by itself. So we're seeing what 1 to 15 squared is. So as you can see, that is pretty darn cool. And imagine if we had to write out print line 1 times 1, print line 2 times 2, print line 3 times 3. It would get very tedious. Even up to 15, it'd be tedious. But imagine if we had to do it for 100 or up to 1,000. And this range doesn't have to start at 1, it can start at whatever number you want. It doesn't have to go up. And when you to experiment, you can actually do 15.1, so it goes down instead. So you can do it like that. You can also do something where you change the step as well. So if I duplicate this, but I'll comment this out. So I'm going to put step 3. Gotta learn to spell first. Step 3. So it will jump in steps of 3. And just so you know what's happening, let me get rid of that. So it prints out 1. He adds 3, adds 3, adds 3. After 13, if he adds 3, you get 16, and that's outside of the range. So you can change the step if you don't want just 1 every single time being added to it. And that is it. That's really all you need to know regarding for loops. Really great, it allows you to run code again and again. Great for going over arrays. Great if you want to repeat code and maybe make some modification based on this sort of, iterator. If you have any questions, feel free to pop me a message. And as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming video, we are going to look at the while loop. So the while loop is really simple. It allows you to check for a condition. If that condition is met, you'll continue running that loop. Once that condition is no longer met, then the loop will stop running. So first of all, we need some sort of variable. So I'm going to call it x, and I'll assign 0 to it. Format of a while loop is the keyword while, open close bracket, and now you put your condition. You would format this the way that we have done with relational operators and logical operators. So I'll recommend checking out those videos. So I'm going to do something simple like x, while x is less than 100. I'm just going to print out x. So simple stuff. So this will run, and let's see what happens. So some of you may already begin to see the problem. It keeps printing at 0, and it's in what we would call an infinite loop. The reason it's not stopping is because x isn't changing. You might think of it, shouldn't it just go up? We have to manually do that ourselves. So if we do that at the end, we just do x plus plus, and remember this is the equivalent of doing x plus equals 1, which is also the equivalent of x equals x plus 1. So we're just adding 1 to x. We don't have to do that. We could do something like x plus equals 2. So we're adding 2 to it every single time. And now if we run it, as you can see, it just runs from 0 to 99. You might be thinking, why didn't it print out 100? And because if you look, the condition is while x is less than 100. Not while x is less than or equal to 100, because if we do that, that will go all the way up to 100. Okay, so that's simple stuff. And obviously in here you could do something like maybe you want to see what the number is if you were to square it, and the final number will result in 10,000. And there we go, we've got the square of all of these numbers. And that's the overall general format of a while loop. If for some reason you need to do an infinite loop, the recommended way to do it is, I'll explain like one sort of use case where this might come in handy. You just put while true, because true is always true, and the condition has to just result in true. So if you just put true there, it's going to continue running. And if I just print line, and I'll say never ending loop. And if I run that, as you can see, we get a never-ending loop. So where would this be, where would this be useful? In games, for example. Games use something called a game loop, and the game loop essentially runs every single frame, is constantly running, and that's checking for input. Based on any input that it gets, maybe the user presses the up arrow or the W key, which is common for moving forward in like a first-person shooter. It will do some sort of update in the game logic. So you'll, let's say, move your character forward, and then you'll display it. So that's why you might want an infinite loop, and you would close the infinite loop within the loop itself. So that's it for the while loop. If you have any questions, feel free to pop me a message, and as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming video, we are going to look at the do-while loop. So the do-while loop is an extension of the regular while loop. So if you're not familiar with that, I recommend taking a look at that video. Once you're done with that, welcome back. We can look at the do-while loop. So the while loop only gets run if this condition here is, true. Whereas the do-while loop, the format is, so if I put do, and we just put curly braces, and at the end put while, and you put the condition in here. So if I put the condition on, same condition, x is less than or equal to 100, and what I'm going to do, I'm going to do a little print line here. So print line, and I'm going to say while loop. Then I'm going to do another print line, and this is going to say, I think you've guessed it, do while loop. So we just know exactly what is happening, and I'm also going to change this to just 10, The only reason I'm doing that is because, you know, trying to scroll through a lot of numbers like this can get a bit tedious. And I'm also going to copy and paste this. So the code inside will be the same. I just want to demonstrate the difference between these two. So if we run it, see what we get. If you scroll up, we get 0, 1, 2. One second, I want to do one other thing. I want to reset x to 0 as well. So x equals 0. So, you know, it's in the same state for both loops. So we scroll up, we get 0, 1, 2, 3, 4 all the way to 10. Then we get the do loop, 0, 1, 2, 3 all the way to 10. So you might be thinking, so far there's no difference. And you're right, there isn't. The crucial difference between a while loop and a do while loop is a while loop is only run if this condition is true. A do while loop, because the condition actually gets checked at the end, will get run at least once, and then the condition is checked. And if the condition is true, you'll get run again and run again till the condition is false. But if it gets run once and the condition is false, it won't get run again any more times, but it's already been run once. To demonstrate it, I'm going to set this number to 100. 100 is not less than or equal to 10. And that's the same condition we got here. But watch what happens is very interesting. And you can... I meant to change this back as well. I meant to change both of them to 100. Okay, so the while loop never gets run because none of this is printed out. But the do while loop, it hits the do while, it prints it out once, and x is technically 101 after this because it's been incremented. So it says, is 101 less than or equal to 10? No, it isn't. So it doesn't run it again. So that's the difference between a while loop and a do while loop. While loop only gets run if the condition is true. Do while loop gets run once. The condition is then checked. If it's not true, it doesn't get run any more times, but it's already been run once. A use case for this could be user input. You might want to get some user input, and then you want to check something. Maybe you want to check the length of the input, and maybe it's a username, and it can't be longer than 64 characters, for example. And if it is longer than 64, you want to do the loop again and get, you know, input again, so valid input. But if the input is valid, you only want to get it once. That's a, you know, a very good use case of using the do while loop over the while loop. So that's it for the do while loop. If you have any questions, feel free to pop me a message. I've just realized I've said like do while loop about 1 billion times in this video, and I look forward to seeing you in the next tutorial. Hello, in this Kotlin programming video, I am going to show you the break statement. So the break statement allows you to exit any type of loop, whether that's a while loop, do while loop, for loop, any loop. I'm going to demonstrate using the while loop, but it can be any loop. So if I simply create a, you know, simple while loop, so x equals 0, and I'm going to say while x is less than 10, I am going to say it's going to print out x. So run it, see what we get. We should get 0, 1, 2, forgot to increment it. Little mistake on my part. Ooh, it's all over the place today. Now if we run it, we get 0, 1, 2, 3 all the way to 9. Okay, so nothing out of the ordinary. But maybe if a certain condition within this while loop is met, I'll keep it simple. But the condition could be anything. It could be related to x. It might not be related to x. If a certain condition is met, I'm going to say, well, if x is equal to 4, we don't want to run the loop anymore. And to do that, we just put break. And this breaks out of this while loop. If I run it, let's see what we get. So as soon as it hits 4, it breaks out of it. Okay, that's simple stuff. Why if we have a nested while loop? So if I put all of this code within another while loop, so I'm going to say var I equals 0. And I'm going to say do while I is less than 5, for example. Okay, let me Okay, so I'm going to also increment I, so I plus plus. And finally, when I print out x here, I'll comment this out for now. When I print out x here, I'm going to format it into a specific string. So I'm going to say I is $I, so we're inserting a variable into a string, and x is $x. So if we run this, see what we get. So we get, I is 0, x is 1, so increments x. Then he goes to the next pass of I and does the same thing with x, etc., etc. What if we put this line back in the break? So as soon as x hits 4, what that does, it just skips 4 and everything else for, this particular while loop. But what if we want to break out of this while loop, or maybe even a higher while, or any loop it can be a combination of loops. If you want to break out of a higher level loop, instead of just the innermost loop. And if you break out of this one, technically you're breaking out of this one as well. To do that is really simple. First of all, you need to label this loop, and to label it, you put some sort of name. So I'm going to say loop, for example. Just loop. Then you put at the end, and that's labeled it loop. And then here, if you say break at loop, watch what happens. As you can see, there's I0, x is 0, I0, x is 1, I0, x is 2, I0, x is 3, and if you look, it stopped. Because this hasn't broken out of this loop, this has said break out of the loop that is labeled loop. And that's it. That's it for the break statement. If you have any questions, feel free to pop me a message. And as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming video, I am going to show you the continue statement, and this can be used in conjunction with loops. It could be a while loop, for loop, do while loop, doesn't matter. The principle is the same. I'm going to be doing it with a while loop, but like I said, any loop will suffice. So I've got a loop already right here, and it runs, and while x is less than 10, it keeps running. But I've got a break statement which gets triggered if x is equal to 4. So watch what happens. It stops, because when x hits 4, as it's getting added, 1 is getting added to every single time, it will break. But maybe we don't want to break out of the entire while loop, we just want to skip that particular pass. So maybe we're doing some sort of calculation, and let me give you an example. So if I change, let's say if I put this as -10, and I'm going to say, well, x is less than 10. I'm going to have another value called I. Let's say number equals 100, for example. And I'm actually going to make these as floats, like so. Yeah, okay. So what we are going to do is print out number divided by x. And I'm going to just delete this temporarily and see what happens. Okay, as you can see, we get a point where it hits infinity. And this point occurs because we are doing division by 0. Depending on the actual programming language, Kotlin is pretty forgiving. Depending on the language, the application might just crash. So you want to handle stuff like this. So you don't want to actually just stop as soon as you hit infinity. You just want to skip this, pass of the loop. And if we undo our code here, so when x is equal to 0, we want to not break, we want to do continue. This just says, as soon as it hits this, ignore the rest of the code and go back up here. But what we do need is this right here. So we'll need this, and we'll need to put it here. And we'll still need to leave it here, but we need it there because otherwise it never gets incremented and you'll just keep being 0. So as you can see, it's skipped over the 0 division. So that is a use case of the continue statement. The another thing you can do is a labeled continue statement. This is very similar to the labeled, break statement that we did, where you can trigger a break on a particular loop itself. You can do that with a continue statement. So I want you to, if you haven't already done so, check out the break statement video, then incorporate that labeling with the continue statement. If you have any questions or you find it, difficult running into any problems, feel free to pop me a message and I will assist you. But as usual, I look forward to seeing you in the next awesome video. Hello, in this Kotlin programming video, we are going to look at functions. So first of all, let me just quickly describe what a function is. Basically, a way of getting a bunch of code, encapsulating it, assigning a name to it, and it allows you to run that code instead of having to write that code again and again and again. You can just call that method, call the function, and it will execute it. Technically, we've already done a function, and that is this first function right here. This is a function. This is the default function that you need. All programming languages will need some sort of default function somewhere, whether or not you manually implement it. By some level, there will be some sort of default function. To create another function, let's say we create one, you can create it before or after, and you can run it any way you want. That's not a problem. Just use the keyword fun, and I'm going to call this epic function. And we're not going to have anything between the brackets at the moment. I'm going to cover that in a separate video. And what I can do is print line epic hello. So now to run this, or if I do run it, let's see what we get. So nothing happens, and that's because though this code is here, it's being compiled, we haven't run this function yet. Until we run the function, so if we do epic function, there you go, it's executed the code. It looks simple, I know. So you might be thinking, what's the advantages of using functions over just print all the code in this main single function? There's two main advantages. One, it helps organize the code better. And two, if I need to, use this functionality throughout my application, imagine if this, contains 100 lines of epic, rigorous code, and I need to run it, maybe here and then here, and then I've got some other code, perhaps, here, and then I have to run the function here. Everything that is within those curly braces will now get executed wherever we have this function call. Also, if we were to modify this, it will appear throughout every execution call as well. So we only have to modify it once, and everywhere that we are, calling this method, it just updates. So this was a very simple example. In the following videos, I am going to cover stuff like function parameters and arguments, which is basically sending values. And I'm going to be covering return values and a bunch of other really cool stuff. So thanks for watching. If you have any questions, feel free to pop me a message. And as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming video, we are going to look at sending values and parameters to functions. So at the moment, we got this function that says epic function. It prints this out. Maybe we want to, have this as some sort of mathematical function. You'll add two values together. So imagine if we have, variable, I'll call it num1, and say assign a value of 9. Call this var num2 equals 10, for example. And I'm just going to call this, addition. Addition. We'll sort this out in a second. And I want to print out the result of num1 plus num2. And if I were to update this, run it, see what we get. Okay, so we get 19, that's fine. But if we want to make a change to this, we have to update these. And you might think, okay, is that a problem? No, but also yes. It is a problem because if you want to call this method several different times or with different values, you can't do that. Not in the current implementation. You'd have to have literally an infinite number of addition methods to compensate for the different combination of numbers. And there are, an infinite number of combinations. There's infinite number of numbers. So to do that, what you want to do is essentially create it so it can accept values. To do that, you provide your variable name here, so num1, you put colon, the data type, so int, comma, num2, colon, int. We don't want these anymore. And here it's got a red line because they say we haven't passed a value for parameter num1 and num2. So if we now pass in that to 4, 5, so you just you just separate the values and the parameters by a comma, and now if we run it, we should now get a result of 9 printed out in our console. And yes, we do. So it's that simple. And if I were to run this again, let's say 3 times, and this has a value of 3, this has a value of 10, I could do a really large number. And we'll get it 3 different times. Obviously, these methods could be slightly more complex than what I'm demonstrating here, but it's as simple as that. You can provide as many values as you want. It could be 1 value, it could be 2 values, 3 values, 4 values, as many as you want. Well, that's it. Pretty simple stuff. As an extra task, I recommend creating methods for the other basic mathematical operators: subtraction, multiplication, division, modulus. Have some error handling as well, because obviously you can't divide by 0, for example, and just other stuff like that. Then after you've done that, as an extra task, an even extra task, further task, you could potentially get input from the user. And if you don't know how to do that, check out the input and output video that I created. Get some input from the user, and that is what you could pass in to one of these functions. And as a result, you get like a pretty basic calculator going. And then even further than that, you could essentially ask the user not only what numbers they want to provide, but also which operation they want to perform. So I'll leave that to you, and I will see you in the next video. Hello, in this Kotlin programming video, I am going to cover return values with functions. So if you haven't already done so, have a look at my basic function video and the function parameter video. Once you've done that, we'll continue. So let's just get rid of these 2 lines. Let's just run it and see what we get. You probably can guess, what the output's going to be. And we get 9. Okay, simple stuff. You might be able to see a problem, and it's this right here. It's not a problem that prevents you from running, but it's very limited. This assumes you want to print it out. You might not want to print it out, or at least not straight away. So a return statement allows you to basically return data from a function to where that function has been called. So whereas parameters allow you to pass data in, you could potentially process that data, which is what we're doing. We're adding them together, and you could return the resulting value. So instead of this, we'll calculate it. So we'll do var result. Actually, as this isn't going to change, we'll do val result equals num1 plus num2. Now, if we do something called return result, I forgot one thing. You need to specify a return type for your function, and at the end you just put colon, then the type of data that you're returning. And if we're adding 2 integers together, it makes sense that you'll be returning an integer. Let's run it, see what we get. We should have 9 printed out, and no, nothing printed out. Though this worked, and it worked fine. This is the same thing as us writing 9 there, just having the number 9. We're not doing anything with it. So what we need to do is create a variable, let's say called var number equals this. Now we could do something like print line. So print the number. And it'll pop up any moment now. As you can see, it shows 9. So with the result statement, the return statement, it just returns the result, or whatever value you want. You could just do return 8, for example. You could put a string. This won't work because the data type, the return type of the data type of the return value isn't int. But if you were to change that, you'll be all good to go. But it just returns it back to here, and this is just assigning it to the number now. The beauty of this is you can use this later on, so you could do like number to number. So whatever the resulting value is, you could now square it. Okay, so as you can see, that's how you use return values. As an extra task, I want you to create another method for basically, powers or, squaring a number. So essentially what I've done here, instead of doing it manually, you would call this function, let's just call it square, and you would pass in one parameter, should be enough, number. You can call it whatever you want in the actual argument section here. Then the return value will be that number times by itself, and then that's what you print out. That's it, simple stuff. If you have any questions, feel free to pop me a message, and as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming video, I am going to show you recursion. So what is recursion? Recursion is just when a function calls itself, and therefore that function calls itself, and it just keeps on going. You generally want some sort of terminating conditions for preventing it from calling itself infinitely, otherwise the application will just hang. So let me just create a function. I want to call it fun. Fun is the keyword for function, so I'm going to call it count. I'm going to call it count up. And what we're going to do is pass in a parameter, call this number, and it's going to be an integer. And now what we are going to say is whatever value we get here, we are going to start at 0. So we're going to say print line number, but we're going to call this method. So we're going to say count up, and instead of passing in number, what we are going to do is say next number equals, or equals itself plus 1. And no, at the moment it don't exist. It equals number plus 1. And now that's what we're going to pass in. And if we run this, let's see what we get. Obviously, I haven't actually called a method here, so I need to put count up. And let's say if I do 10. So it's just compiling. As you can see, it's had a problem. And the problem is it just kept going, and it was counting too many times. So it's essentially crashed. So instead, what we want to do is actually, sorry, I was meant to start here at 0. I was meant to say, so what we're going to say is we're going to have two numbers. So we're going to have number, and we're going to have starting number, colon, int, and this isn't the starting number, that is. So we are going to say starting number is 0, and the number we want to count to is 10. So we're going to say print starting number. Next number is starting number plus 1, and let's see what we get. Sorry, we need 2. So the next one, or the second parameter, should be number, which is the final number. the end destination. You could say that destination number or end value. And again, it has the same problem. It's just running too many times. And essentially the application is crashing. So, but instead, what we want to do is here, we want to do a check if starting number is less than, basically the end number, then we want to call this method. So we want to have recursion. Otherwise, we've hit the destination. And if you look, any moment now, as you can see, it counts up. That's a very simple example of recursion. There are some really cool things you can do, such as factorial numbers. And I recommend, as an extra task, looking into factorial numbers and basically calculating a factorial function. If you have any questions, feel free to pop me a message. And as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming video, we are going to look at default and named, arguments. So if I just quickly create a function, it's going to be simple, and I'm going to call it add, and we can pass in 2 parameters into here. We could pass in num1 colon in. So we've already done this before. This is part of the parameters video, so I recommend checking that out if you haven't already done so. And I'm just going to print it out. You could do a return statement. Again, I've covered that as well, but the principle is the same. So do num1 plus num2. Let's see what we get. Actually, we're not going to get anything because I haven't actually run this method. So I'll wait for it to compile. So I need to put the actual function call here. So add, passing 2 values, 5 and 8. That is fine. I'm happy with those values. So we should get a result of 13 because 5 plus 8 is, well, 13. Okay, that's all great. What about if we want to have default arguments? So if we don't pass in any arguments, so all of the arguments, we want some default values. It's actually really simple. So if I put equals afterwards 1, and I put equals again 1, the arguments by default now will be 1. Obviously, we could do 1 and 2. They don't have to be the same. And obviously, these can be different data types. And I'm going to cover that towards the end of this video. So if I go back to this, at the moment, if we run it, nothing changes. Nothing at all. And the reason nothing changes is because we're actually passing in values. If I commented this out, and I just did this will yield a result of 2 because we've passed in no values, therefore it gets the default values of 1 and 1. But watch what happens if I were to still keep this function call but remove these. We get an error because it says no value passed for parameter num1 and num2. There we go. Okay, so that is, just one little thing to bear in mind. I'm actually going to create one extra function. I'm going to call this epic function. And I am going to have, a character first. So I'm just going to call it letter, for example, colon char, comma, and I'll have a number colon int. Okay. And what we are going to do is call this method. We call epic function. And the first parameter should be a character. So I'm going to pass in, I, comma, and for the number I pass in 65. Like the values don't really matter. And I'm just going to do a couple of print lines. So I'm going to print line. I'm going to do dollar letter and dollar number. So we just want to see what we get. Obviously, the way you manipulate them is totally up to you. And if we wait for this to compile, okay, so we get I and 65. Okay, so that is pretty darn cool. Whereas if we were to, let me show you something. if with this one here, I put this, we get a result of 6. And the reason we get that is even though we've only passed one parameter, it's getting assigned to the first parameter, and the second one has a default value, so it's okay. Whereas what happens if I try and just only assign one parameter here, or pass in one parameter? So if I say epic function and I just say 45 and I put comma, we get an error. And that is because the first parameter is meant to be a letter, as it's telling you. But what we can do now, how it says letter here, we can actually override that. So what we can do is this. So if we put number, so actually first of all we need to have some default values for me to demonstrate this. So if I have a default value of a, and we can have a default value here as well, maybe we can have a default value of 9. Okay, so this will work fine because we got default values, but if I put a number like 45, it gives an error because by default the first value that is expected is a character. But if we only want to pass in values for the other parameters and the previous ones have default parameters, that's fine, but you just got to do a slight little change here. So if we only want to pass something in for number, you have to do number equals another value. So if I say 65, see, we get no errors now, and if we run that line, we should get a and 65. A and 65. So you use the default character parameter, but because it's detected that we've passed in a value for the parameter that's labeled number, it's used that value instead of 9. So that's it for default and named arguments. If you have any questions, feel free to pop me a message. And as usual, I look forward to seeing you in the next video. Hello, in this programming video, we are going to look at Lambda functions within Kotlin. So if you don't already know what regular functions are, I recommend checking out, the videos that I've created on that. Once you're done with that, we'll look at Lambda. So now let me just, briefly explain what Lambda is. So Lambda is, it's a function that essentially has no name. It's defined with, some curly braces, and it actually takes a variable as a parameter and the body of the function. Sounds a bit confusing, so let me just demonstrate it. So to create a Lambda function, so I want to create one that multiplies numbers. So I want to call it multiply, and it's going to have some parameters. So let's say num1 colon int, num2 colon int, and now I'm at the end. What we need to do, I'm going to call it lambda. So lambda, and then what you do is colon, and this is the actual sort of lambda expression that you're passing in. And we're going to say int, and we're going to call this unit. Like, so actually, no, it is unit, sorry. Well, I'm calling it a unit. Okay, in here to add the values together, so we could do val result equals num1 plus num2, nothing new here. And to actually, do something with it, so we are going to do this here, lambda. So I'm going to say lambda. I'm going to pass in the result, and now we need to call it. To call it, it's a pretty interesting way you do it. So you create a variable. You don't directly call it. You create a variable first. So we call it val. We don't need to change. Then, so if I call this lambda colon, and I'm gonna, this is gonna be an int because that's what the data type is. Then the Kotlin unit equals, now you put curly braces, and we are going to put int again, and we are going to print it out. So this is the actual function, part of the functionality is literally going here. So s is just the result, I'll put a semicolon. But essentially, like, the functionality of, you know, the result is going here. And now if we run it, to run it, you do multiply. You do multiply, and, you know, passing some variables. So it's 4, 5, and the last variable is literally the lambda that you created. So if I run this, and you'll see our result should be 20. So as you can I didn't time ago I added this together. Okay, my bad. Now if I run it, okay, there we go. We've got 20 using lambda expressions within Kotlin. Quite a bit going on here. Can be a bit confusing. So if you have any questions, feel free to pop me a message. I'll also provide some really cool resources to learn more about lambda expressions with the video. And as usual, I look forward to seeing you in the next tutorial. Hello, in this Kotlin programming video, we are going to look at high order functions. So high order functions, also known as higher level functions, are functions which actually accept a function as a parameter. So instead of, you know, accepting a variable like a string or an int, it accepts a function, so which is, you know, pretty darn cool. So let's just dive straight into it and implement the function. So if I'll say fun epic function, so I am going to, obviously the parameter that you are passing could be whatever you want. I'm just going to deal with integers. I love integers. I'm going to say num1, and integer, comma, num2. This is another integer and comma, and this is where our function, you know, is placed. So I'm just going to call it fn colon, and we're going to say int. So we just put the data type there. We don't put anything else. Then we put like sort of the data type that is, you know, returning. So int. Then you put colon unit at the end. Okay, now in here, what we can do is we can, you know, create a variable. We'll call it result. We must say equals fn, and we'll simply pass in these values. So num1, num2, and we're just going to print this result out. So at the moment, we don't know what's going to happen. We haven't implemented all of it. So if we go to our main, what we are going to do is create a variable, call it fn colon, and obviously it's going to have the same format, so int, and it's going to return an integer. And basically we're doing a lambda function here, so we're doing an inline lambda function, and we are going to say int, not int, what am I doing? So it needs to be the same name as these, so num1, num2, num1, num2, and what we are going to do now is, and you know, we can actually just do something with it. So the actual format will be num1. Obviously we could put a string here, but I'm just going to say num1 times by num2, for example. And now to call the function, just do epic function. We pass into, let's say, numbers of 5, 9, and then for the last part you just put fn, so you pass in this lambda. So if we run it, we should get a result of 45. Okay, so we got 45 right here. I'm thinking, okay, can we not just do the regular function? In this scenario, you can. But look at what we've done. The calculation for 5 times 9 did not occur, you know, technically within the curly braces of epic function. There's nowhere that we've done 5 times 9. What we did do, we passed in 2 numbers, you know, normal stuff, but we also passed in a function. This function happened to be this lambda function. It could be some other function, it doesn't have to be a lambda, but I've just implemented a lambda, and that's what we passed in here. So what that ultimately meant was we were able to use this function anywhere here that we wanted. And the beauty of that is we might have, similar functions. So let's say if we have a calculator, you might have a function for add, which is just, adding two numbers. You might have a function for divide, multiply, subtract, and essentially you still just taking two numbers and you just adding them or multiplying them or dividing them or subtracting them. But the actual function call essentially will be, the same, because if they're named the same, and if you want to do some other sort of calculations with it, maybe here you're recording some statistics or user data, instead of having to do that again and again, just passing the unique function that you want to use, and then you're good to go. So that's it for higher order functions. If you have any questions, feel free to pop me a message, and as usual, I look forward to seeing you in the next tutorial. Hello, in this Kotlin programming video, we are going to look at inline functions. So the inline function is used to enhance the performance of higher order functions. The inline function basically tells the compiler to, copy parameters and functions to, the particular place that it's being called. Let me just implement one so I can show you. So if I call it, inline func, so I am going to put curly braces in here, the print line, and I'm just going to say epic call, and obviously we haven't created the function yet, so we do the keyword inline, then we use fun, for short for function, inline func, so we're naming it the same obviously, and we here are going to just have my fun colon. So this is a function right here, and it's going to be accepting a type of unit, and then in these curly braces you have to put what we call it, so my fun, and in here we can now do a print line. Something's messing up. Oh, sorry. Don't need the curly braces, sorry. It's just like this. Print line. And if I say code inside this epic inline function, so if I save that, there we go. So it's got the epic call, which is what is done here. So we have the inline part right here. Then here we have like a little extra function part as well. So that's how you implement inline functions. If you have any questions, feel free to pop me a message. And as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming video, we are going to look at exception handling. We're going to start off with a simple try catch block. And what is exception handling? So let me just create something really simple. I'm going to create a variable, and I'll call this number. And I'm going to say number equals, I'm going to do a mathematical calculation. Actually, I'll create two numbers. So imagine if you get any input from the user. So number 1 equals 100, for example. Number 2 equals 0, and then we're doing some sort of divide calculation. So we are going to do var result equals, probably best if I do val, considering these shouldn't really be changing, like so. Result equals num1 divided by num2. So let me print it out. So let me print it out. Result. Let's just see what we get. So if we wait for it to compile, and we get a result of, as you can see, basically we get an error. Exception in thread main java.language arithmetic exception, division by 0. You can't divide by 0 in mathematics. Therefore, this will cause errors in your application, and it will make it crash. The try catch block, the exception handling allows you to overcome this, and it's not just for mathematical division or any math in general is anything where some sort of runtime error might occur. Maybe you're trying to load a file and the file may or may not exist. Instead of the application crashing, that's not a good user experience. You'd rather let the user know there's something going wrong. Maybe some sort of box pops up and it says can't divide by 0, or can't find, maybe it's a save file. Do you want to create a new file if it's a game, for example? So it's better to inform the user than just crash it. So what we do is instead we put the actual calculation part, the part that could crash it, within something that's called a try block, like so. So we put this inside of here. It's got a red line. That's because we haven't completed it yet. And we'll also put the print line there as well. And if there's a problem, then we want to do catch. And the catch is going to be like an error. And we just put the exception that we think it could be. So in this case, the arithmetic exception. The best way to find out is force that error to occur, and it will literally just tell you the exception in the console. And now we can do something else here. We can make some sort of box pop up. We could maybe save some sort of diagnostics and send that to our own server for some sort of statistical analysis. But I'm just going to print out this error, and we'll see what we get. So if I run this, that as you can see, it says java.lang.arithmetic exception divide by 0, but it's not red. The application didn't crash this time. So if I put print line here, and I put, I'll just say after the check, this code will still now run. The application won't crash, but the rest of the try block will halt as soon as it hits a error. But if I change these numbers, so I replace this with a 20. So 100 divided by 20 is possible in mathematics. So we should get a result of 5 printed out. And we get a result of 5. So that's the best way you want to actually handle errors that may occur. If you have any questions, feel free to put me a message. And as usual, I look forward to seeing you in the next video. Hello, in this video, I'm going to show you the try catch block, but as an expression, as a return expression. At the moment, we've got a try catch block here, which just handles, if we put a divide by 0, so any sort of arithmetic error. Actually, if you haven't watched the try catch block video, recommend checking that out, because this is built on top of foundations that we added in there, and this import is automatically added when we use the arithmetic exception. Okay, so what we are going to do, I'm actually going to get rid of all of this. I'm going to get rid of all of this. I'm going to create a new function. I'm going to say convert, and this will take a string. I'll just call it string variable, and the data type is of string, and we are going to return an integer. So we are going to take a string and we're going to convert it into integer. So if we get some user input and maybe we get the input 5, it might be stored in the string, but we might want to manipulate it mathematically. So this is just moaning because we haven't got a return type yet. Don't worry, we're going to handle all of that. We're just going to put return try. So the only difference is we have a try block. So I'll just do the normal try block that we are used to. And in here, we are going to do integer.parseInt. So we're just going to try and parse this string variable that's passed in. Basically, we're trying to convert it to an integer. And catch. So if there is some sort of arithmetic exception, we'll just put 0. Okay, so you might be thinking, okay, what's happening here? There's a slight little difference, and if I put a return statement, that is the try catch block as an expression. So what happens is whatever result is in here gets returned, and if it goes into the catch block, whatever results in here gets returned. So if he successfully converts it, we'll return the number. If not, we'll just return 0. So let's actually run this. To run it, well, first of all, we need to create a variable, and I want to call this string equals get number. Convert. So we want to call the convert method, and I'm going to pass in the number 98, or the string 98, which is obviously a number, and then I'm going to print line, and I'm going to say string, like so. So if I run it, let's see what we get. There you go, we get 98. Let's say if we put, I don't know, P. Let's see what we get if we put P. Okay, number format. Actually, no, we need to handle for that error. Number format exception. Number format exception. Let's try running this again. So there we go. Okay, it was just the wrong exception. So if we put the letter P, we can get rid of this import. It's no longer used. If we put the letter P, it's not a valid number. So we just return 0, whatever's in here. And the return type could be a string, doesn't have to be an integer. It could just be some sort of message that you're saying to the user, oh, success is a number or it's not a number. And if I put a number like -8 in here, we get a result of -8, but this is actually in number form. So that's how you use a try-catch block as an expression when you are returning it, and basically the result in either the try or the catch is the returned data. That's it. If you have any questions, feel free to pop me a message, and as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming video, we're going to look a bit more into exception handling, and more specifically, multiple catch blocks. So we've got a single sort of catch block right here, but you might want to account for different errors. So imagine if I create an array. So var, I'll call it ARR equals int array, and we put it as a size of 10. And remember, computers start at 0, so the first index in the array is 0, last index is 9, so the size -1, which gives you 9. So if in here, instead of doing it as a result, we want to assign it to array, and in a particular area index, let's say we want to assign it to the last one, 9. And we want to print that result out. Actually, we don't want to print it out. That is fine. The printing out isn't important. Actually, you know what? I'll print it out, and I'll print it out here. So we'll do. So what we actually want to do is just essentially print it out here. And we're just going to loop over the array. So we've already done this before. So, we say value in array. And we got a separate video covering this, so feel free to check that out. I'm just going to print out each value. Okay, simple stuff. Now, what we're going to do is essentially force some errors to occur. So if I was to run this, at the moment, no errors will occur. It will say we get 0, 0, 0, 0, 0, then we get 5 because 100 divided by 20 is 5. But what if we accidentally do this? This is out of bounds now. This is an out of bound error, because even though we have a size of 10, 10 represents the 11th index because computers start at 0. So if we were to run this now, we get an error. The arithmetic exception cannot handle this error, it can only handle this one. It says exception in thread, array index out of bounds exception. Luckily enough, there's an exception for that as well. So we just have to put another catch and we'll call it error, and it is array index out of bounds exception. And if I print line error, we'll essentially get that error now, and the array will not be modified. As you can see, the array is not modified, and it just says index 10 out of bounds for length 10. Okay, so you might be thinking, oh, there could potentially be, hundreds of, errors, and you're right, there could be loads of exceptions, and we don't expect you to try and handle all of them. That's the reason you can just do a blanket sort of, general exception, and this is just except code exception, like so. And I'm going to print two things here. I'm going to say general error, and then I'm going to actually print out the problem. So instead of having this here, I'm going to comment this out, and you'll see that even though we're not handling for this specifically, this will essentially pick up any just exception that we haven't specifically accounted for. As you can see, the general error, and it gives us the error as well. And you might be thinking, okay, would we not just have one of these general one of these catch blocks instead of having all these? The reason you wouldn't is if you want to do something specific depending on the error. Depending on this error, you might want to say no division by 0. Maybe depending on this error, if you are trying to insert items into a list, you might want to say something like you are going too far into the list. So you are making the error, the sort of message, the sort of response specific to the exception. But it's always good to have this final catch block for anything that you may potentially miss or you may not realize that could cause an exception. So it's always good to have it. So that's it. Pretty simple stuff. But if you have any questions, feel free to pop me a message. And as usual, I look forward to seeing you in the next video. Hello, in this Kotlin exception handling video, we are going to look at a nested try block. So first of all, let's create some arrays. So I'm going to say array 1 equals int array of, and I'm going to put a bunch of values. So I will put 1, 2, 3, 4, 5, 6, 7, 8, for example. And I'm going to say var array 2 equals int array of, and we'll put some more values like 1, 0, 5, 0. We'll leave it at that. That's fine to demonstrate it. If we have our simple first try block, and then we have a catch. Obviously, the catch it, you can make it specific for your example. So I'm going to say error, and this is going to be array index out of bounds exception. It will all make sense in a moment. I'm going to create a for loop, and this for loop is going to be item in array 1 dot indices. So in here, we're going to have another try catch block. And here, what we're essentially going to do is print something out. We are going to print out the first array, so array 1, and we are going to use that as the index value. And the .to string, so it's going to convert this to a string. Then we are going to essentially do division here, plus, but this is just formatting it to show what it will look like. And the next part is array 2, and again is just of item plus, and we're going to say equals, the actual result, and the result will be array 1 item divided by array 2 item. And now we just need to handle some error. And the error we're going to handle is arithmetic exception, and we are going to print line please no division by 0. So if we save that and let's see what we get. Okay, so we get a few different things. So first of all, we get 1 divided by 1 is 1. Please no division by 0. So the second one is 2 divided by 0, which gives you an error. 3 divided by 5 is 0. Why thinking why is it 0? Because it's doing integer division, so you're losing precision, but that don't matter, that's fine. And then again, 4 divided by 0 is 0. And also, here I never actually printed anything out. I'm going to print line, and I'm just going to say array sizes do not match. So if I run this now, the only difference is we should get an extra print line. So I'll scroll up, so we get the same stuff, but when we get to here, we've done 4 divided by 0, which gives us please no division by 0, but then it's trying to do 5 divided by the 5th element here, or at index 4, because that complete start at 0, but there's nothing here. So it says array sizes do not match. So this is a great example of where you might want to use a multiple try-catch block. The first try-catch block is just checking if you are within the bounds of the arrays. The second try-catch block within the for loop, it doesn't have to be within the for loop, it could be, it's totally up to you depending on the scenario, handles the arithmetic exception of division by 0, and these can have multiple catch blocks as well. So that's how you do nested try-catch blocks. If you have any questions, feel free to pop me a message, and as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming video, we are going to look at the finally block with the try-catch block. So the finally block is really simple. You just put finally, there's no brackets like this, and whatever code is here will be run regardless of whether or not the try is successful or whether it caught an error. So let me demonstrate. If I do print line, and I'm going to call it finally. So as you can see, we got 100 divided by 20. This should not produce an arithmetic exception because we're not doing something like division by 0. So if we run this, as you can see, it printed this out here as 5. It did the finally block and obviously did whatever was outside. So let's force the error. So if we do division by 0 now, even though we force the error, the finally block is still called. So the finally block is always called at the end, regardless of whether or not an exception is called. So if you always want code to be run that's linked with this, put it in the finally block. So that's it. That's all the finally block does. Pretty simple stuff. But if you have any questions, feel free to pop me a message. And as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming video, we are going to look at throwing an exception ourselves. So, if we want to throw an exception, maybe, for example, we are, doing this division. So division by 0 is not valid, but division by like 6 is fine. But maybe we don't want to have division by a negative number. Maybe our application does it, and we're getting input from the user, so we need to handle that. So we could do, maybe here we could do num2. If it's less than 0, then it's a negative. And then here we would, if we want to throw an exception, put the keyword throw, then the name of the exception. So I'm going to say arithmetic exception. Then you put open close brackets, and in here you put any information that you want. Usually, if you were to do division by 0, the exception that you will throw is division by 0. Whereas on this, we're going to say no minus numbers. So if I run that, so as you can see, it says no minus numbers because it is a minus number and it's been thrown into the arithmetic exception which we're handling, and it prints the error out, which is this. And that error could be a status code, so based on that you could do something as well. So I'll recommend as an extra task, have a bunch of if statements or if else statements here. Instead of passing in something like this, passing a number, for example, and depending on what it is, just print something else or do something accordingly. So it's that simple of throwing your own exception at a particular point and then running the code that's within a particular catch block. Simple stuff. But if you have any questions, feel free to pop me a message. And as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming video, we are going to look at nullable types and non-nullable types. So essentially what that means is if you have a variable, for example, so let's create a variable called epic var, and we'll have a data type of integer. And okay, that is fine. We could do epic var equals 7, for example, and we can do a print line of epic var. Run it, and we'll get 7 printed out. Nothing new. This is stuff that we've done before, but maybe you don't want to assign a value yet. You want to assign null, and based on a certain condition that you could check for later on, if it's null, you could do something accordingly. So if I try and assign null to it, you get an error. It says null cannot be a value of a non-null type int. So if you want to make the variable accept the null value, after you put your data type here, if you put a question mark, it means it's a nullable data type. And if we print that out now, not only will that compile, we'll get a result in the console as well, which you'll see in a couple of seconds, which just obviously says no. So that's the difference. You just have to put a question mark if you want it to be a nullable data type. So whether it's an integer, a string, whatever it is, doesn't matter. If you don't want it to be nullable, don't put a question mark, and that way it cannot accept a value of null. And if you want to do a check, so maybe you want to say if epic var equals null, for example, you could do something accordingly. If it equals null, maybe you want to assign some sort of default value of, I don't know, 1, for example. And that is, again, that's just a simple use case of where you might want to do it. So if it is null, maybe initially you set stuff to null, you get user input. If you do not get user input for epic var, you know that you haven't received it. You might be thinking, okay, can I not just assign 0? But 0 might actually be a valid input. So, if you're accepting numbers, for example, and it might be, how many cars do you own? 0 is a valid number. You might, own 0 cars. You might own 10 cars. You might own 100 cars. But if this is a nullable data type, and by default it has the null value, you can check, okay, if it has null, then you could, just maybe put 0 in the car example. But in some other example, you could assign some other default value. So that's the difference between nullable and non-nullable types and how to implement them. Really simple. If you have any questions though, feel free to pop me a message. And as usual, I look forward to seeing you in the next video. Hello, in this video I am going to show you smart cast in relation to nullable and non-nullable types. So I'm going to remove this little print here. I'll actually remove this. So if you want to essentially do a smart cast, and a smart cast is used when you're doing conditions, like an if statement. If you want to check if your variable is not null, so like not null, that is a smart cast right here. And as a result, we put a print line. So we've checked it and we say not null. So if we run this, nothing should be printed out. As you can see, nothing is because epic variable is null. Whereas if afterwards, immediately after, I'll just put epic var equals 9, now it has a value assigned to it, and as a result, epic var is no longer null, so we've done the smartcast check, and it prints that out. Whoa, what happened there? Done that. And okay, so that's one way of doing it. You can also do use the is for smartcast. So if we want to say, let's say instead of this we put any, so it could be any variable and any data type. And we assign a value of 9. We could say, instead of this we could say if epic var is int, for example, then we say print line epic variable is an integer. So we are doing a smartcast of checking if it is an integer. We haven't specified integer as the data type. So based on the data, it will determine if it is an integer. This could be string. You can also do not is. So if you want to see if it's not an integer, so if you want to do smartcast in that scenario, that is possible as well. But I recommend doing that as an extra task yourself. And that's it. If you have any questions though, feel free to pop me a message. And as usual, I look forward to seeing you in the next video. Hello, in this programming video, I'm going to show you the unsafe and safe cast operator in the Kotlin programming language. So sometimes, for example, if I create a variable, call it epic string, and I put, what should I put? I will put the data type any, and I'll assign it to null. Okay, simple stuff. And if I create another one, actually I also want to call this epic. I want to call this str, so short for string, colon, the data type is string, equals, epic. If I say as string, so I'm doing a smartcast here, and if I print this out, let's see what we get. So, sorry, no, that's not the command. That's the keyboard shortcut. Okay, so if we wait for it to run, we get an exception. Obviously, you can handle this exception. Feel free to have a look at the exception handling part of this series, and this will be the exception right here. But we get an exception because, it's null, and this is an unsafe cast operator. Luckily, there's a safe way of doing it. So instead of doing this, if we do this, if we just put the question mark after it, and what is going on? What is going on? Oh, sorry. What am I doing? What am I doing? Sorry, we meant to put it there, and then we meant to put it there. There we go. I was wondering why that wasn't working. Did not mean to do that. Let's click run. Okay, let's want to run it again. Okay, so it prints out null, and this just makes the smartcast operation safe. So basically, it provides a safe cast operator, and it allows it to safely cast to a type. It returns a null if casting is not possible, rather than throwing an exception. And that way, you can handle using a conditional statement the null value, and then maybe do something accordingly, provide a default value, or inform the user that maybe their input is invalid. Maybe they haven't input anything, for example. So that's how to handle unsafe and safe cast operation. Simple stuff, but really useful. If you have any questions, feel free to pop me a message. And as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming video, we are going to look at the Elvis operator. So first of all, let me just show you a quick example. So if I create, a couple of strings, so string 1 and string, I'll allow it to be a nullable type for the purpose of this video, and then for string 2. And again, this potentially could be nullable, but I'm just going to say this actually has a string, so hello world, semicolon. And now we're going to create a variable for length 1. This is going to be of data type int, and we're just going to do an inline if statement. So we're going to say if string 1 doesn't equal null, then essentially we want to get the string's length dot length string 1. Let me just scroll over a bit. Actually, let me just change the preferences so we have line wrapping, word wrapping. So where would this be? Probably in general use soft wraps. Could that be it? What's that actually done? Don't think that's it. Might do it afterwards, but let's just make sure that isn't what I want. Yep, that is. It just shows the arrow, but again, that don't bother me. Okay, so string 1 dot length elf -1. So this basically says if the string is a null, then get the length, otherwise just return -1, and that's what's assigned to the integer value. And we're going to do the same, but we're going to have length 2, and for this it's going to be string 2, and gain the string 2 length. Next, we are going to simply print these out. So print length and print line length 1, length 2, and if we run it, let's see what we get. We get -1 and 11 because the first one has null. So the Elvis operator basically just simplifies this part of it. So I'll comment this out for now. So we do var length 1 equals, so we still want this as an integer data type, equals, and string 1 for question mark dot length question mark colon -1. Okay, so this is just the same thing as this part here, and this is the same thing as this part. That's the way to think of it. So this is saying if this is not null, then get the length or whatever this property or method is of this variable. If it is null, then return this value. And as you'll see in a very short moment, this produces the exact same result. One benefit of this is it's shorter. You only have to repeat a string, this variable once in there. Therefore, less likely to make mistakes in terms of, especially if the variables are named with similar names. And we should get the result of -1 and 11. So there you go. That's how the Elvis operator works. Pretty simple, really. You can combine it with throw and return exceptions. I recommend that you do that as an extra task. But if you have any questions, feel free to pop me a message. And as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming video, we are going to look at the list collection, and more specifically the list of method which allows you to create, lists. So lists have, a fixed size. So let me show you something about lists. So actually, let me describe what a list is. It's essentially it's an interface. It's a collection of elements. They inherit from the actual collection class. They are immutable, and its method supports only read functionality. So once the data is set initially, you can't change it. So if you want an immutable collection, so almost an immutable array, list is the way to go. So if I create a very basic one, and I'll call this basic list, and equals list of, and then we can provide parameters in here. So let's say 1, 2, 3, values, and there we go. And we could loop through these values using a for loop. If you want to know more about these, feel free to have a look at that part of my series. For item in brackets, for item in basic list, and that basically will get every element and put in an item. I'm just going to print it out as item. Okay, so this is a very, very simple example, as you can see. So once it's run, we should just get 1, 2, 3. Let me go on a slightly more complex example, and I'll call this basic2 list. And for this, we can mix and match. So we could have some numbers, we could have some strings. So maybe I'll have this one as a string. So I'll say hello. And they don't have to alternate, that's just the way I'm doing it. I'll show you. I could put another one here. I could say Farhan, which is my name. And in here, I'm going to print out all the items for basic2. And I'll just put a print line between these. And it's just going to be an empty print line. Just so there's a gap. And here we go. Okay, so that's a slightly more complex list. If you want to specify the data type, so that way when you're writing here, it will only accept certain data type, that's really easy. So you can do var, let's say int list equals, use that, specify the data type after here, you put colon, list, angle brackets, then you put the data type, so integer in this case, and we put list of angle brackets integer, and this should be a capital I, open close brackets, and then you put your values, so let's put 10, 20, 30, 40, 50, etc. If I copy this, the actual looping through it is the same process. So this will be called int list. And as you can imagine, you could have a Boolean list instead. This and this will be Boolean, and the values inside will be Boolean. You could do the same for string and any other data type, really. But I'll leave that as an extra task for you. Okay. Okay, so we got that printed off. I'm gonna. Oh, my throat's a bit. Oh, it's all right now. I think it sounds okay. So now the last one I want to show you is the any list, which is essentially the equivalent to what is inferred by this data type. So if I put var any list, and this basically allows you to mix and match the data types. You put colon, list, angle brackets, any, then you put equals list of angle brackets, any. And I love this any. Some languages don't have stuff like this, and Kotlin is just really amazing. So if I put 10, 20, and then I put my name, and I can print this out as well. So if I go to here, I want to change this to any. There we go. Okay, so if you want to basically get a particular element, so you don't want to loop over it like this, you can do something a bit more specific. So if I do print line, so let's say if I go to any list, I could do dot get, for example, then I could provide the index. If I provide 1, remember computer start at 0, so this will be 0, 1, 2. 1 should return a result of 20. There we go. There's a bunch of other stuff. We can check if it's empty. We can also drop stuff as well, so we can actually remove part of it. we can check if it contains a particular element. We can check if it contains a whole nother list. I'll provide a link to all of those methods, but as long as you understand everything that we've done today here, you're all good to go. So thanks for watching. You've done quite a lot, so if you have any questions, feel free to pop me a message. And as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming video, we are going to look at mutable lists. So a mutable list is a list that doesn't have a fixed size, therefore you can add extra items to it. Unlike the immutable list using the list of function, which has a fixed size and you cannot add more items to it beyond the initial creation. So if you want something a bit more flexible, the immutable list is the way to go. So let me show you like a little basic example. So I'll call this mlist equals mutable list of, and I'll ignore this for now. And in there, you just basically provide your data type. So what you can do is in here, you provide your data type, and then before here, you would provide the data type. So if I did int, and then if I put int, this is of, type int, for example. And why is that morning? This needs to be mutable list. There we go. Okay, I'm not going to do it like this simply because I've already essentially covered all of this in the list of function video. I recommend checking that out. So I'm just going to let Kotlin automatically assign the data type based on the one it thinks is the most relevant. So the mutable list of function, and let's assign some values to it. So if I assign 10, 20, 40, 80, so it's just doubling, and we can print it out by looping over it. So we can do a simple loop. So we can call item in mlist, and it's going to print line mlist. Okay, so if we were to run this, we should just get 10, 20, 40, 80. And there we go, we get, I've literally just printed out the entire list. I'm meant to print out item, like so. So if we run that, we should just get 10, 20, 40, and 80. And that's what we get, simple stuff. So if we want to add more items to the list, we can do that by doing mlist dot add. Because this will be of an integer data type, so make sure you specify the correct sort of data type. If I put 65 here, you can add as many as you want. I'm just going to add the 1. Copy that, and I'll paste it here down here so we get it printed out again. And I'm just going to put a empty print line, and this will just basically put an empty line. So it separates the two print outs. And as you can see, we get 10, 20, 40, 80 for the first one, then 10, 20, 40, 80, 65. So the dot add just adds it, well, literally at the end. What we can do is if we want to specifically, add it to a particular element. So I want to replace this one here. Remember, computer start at 0, so this will be 0, 1, 2, 3. So this is our index 1. So to replace that, we have to do mlist.add, but instead of just providing the element, we provide the index first. So this is our index 1, and maybe I want to provide, I'll say 27, which is my age currently, and I'm going to just copy this. So if we run it, so let's see what we get. So as you can see, so if you go to the first one, 10, 20, 40, 80. Next one, 10, 20, 40, 80, 65. For the next one, the second value has been modified, which is at index 1. So that's how you basically change values for a specific index. Pretty simple stuff, but really powerful. So if you want more functionality out of your list and you want it to be mutable, so you can add and modify existing values, this is the way to go. If you have any questions though, feel free to pop me a message, and as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming video, we are going to cover array lists. We're going to use the array list of method to create it. So an array list basically combines an array with a list. If you remember arrays, if you don't, feel free to take a look at the video. But arrays essentially have a fixed length, lists do not, and it's basically a combination of both of them. So you can read and write data to it afterwards, and you can just add as much data as you want. So if I create an example, so var, and I'll call it epic a list, and I'm going to make this an integer type. So I am going to say equals array list of, and the type here is going to be int, and I'll assign some values of 3, 5, and 7. Semicolon. You could have a different data type, string. You could have the any data type, so which permits any data type mixing and matching. So feel free to take a if you've been watching this series, then you'll know how to do this the same process. So if we want to loop over this, we could just do a simple for loop that just says for every item in epic a list, and we'll just print out the item. We'll print out item, run it, and we should just get 3, 5, and 7 printed out on different lines. There we go. Yeah, there we go. We have 3, 5, and 7 printed out. Okay, so that's pretty simple. Let me show you how to actually add an item. So if, for example, I want to add an item here, I could do epic a list dot add, and you can specify if you want to add just an item in general, which will add an item at the end, or you can specify to add an item at a particular index, and that overwrites that index, whatever's there. So I'll demonstrate both. So if I just say add 67, and I'm going to run this for loop again, and I'm going to do a print line. So println. So this is just an empty print line. Okay, so we get 3, 5, 7. Then on the next iteration, 3, 5, 7, and the additional 67. So let me show you how to, let's say, overwrite the number 7. So number 7 is the last index, or at the moment it is the last index before we've added another value. Remember, computers start at 0, so this is the 0th index, the 1st index, and the 2nd index. So this, the 3rd value, is at the 2nd index. To change that, you would do epic a list dot add, and just specify the index first. So 2, comma, give a value of -7, for example. And now, if I just do this again, and I'm just going to do a print line here again. And let's see what we get. So let's take a look, scroll up, we get 3, 5, 7, 3, 5, 7, 67. On the next one, 3, 5, and you can see 3, 5, -7, 7, 67. So can you see what happened? So this doesn't overwrite. If I said that, sorry, I made a mistake. What I meant to say was it inserts it there, and it basically just sort of moves everything else around it. So if there's already something there, it just moves everything else forward beyond that particular point. So that's great. If you just want to insert something in the middle but don't want to override something, an array list is the way to go. And I'll say the final couple of methods that I really want to show you is the get and set methods. So instead of doing it like so, if you want to get like a particular element, so if I do print line epic a list dot get, you can just get a particular index element. So if I say dot get, or should I say dot get 0, which is the first index, So as you can see, it prints out 3, which is the first index. And if I were to do set, so if I do epic list dot set, and for the set method, we need to specify the index, then the value. For the index, I'll say 0, comma, and I'll specify a value of 9. Now I'm just going to run this loop again. Do a print line, run it, and let's see what we get. Okay, so we on the final batch. As you can see, if you want to overwrite a value at a particular index, you use the set method. If you want to just get one individual value from a particular index, you use the get method. And that's it. That's it for the array list, which is a combination of arrays and lists. If you have any questions, feel free to pop me a message. And as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming video, we are going to look at the map collection. Map collection allows you to store data in a key value pair. So you specify not only the values that you want to store, but the keys in which you will, access those values as well. The keys have to be unique, because otherwise, how does Kotlin know which value you're trying to retrieve? So let's create a basic implementation, and I'll call this map and equals. So equals. I'll show you the generic sort of interface first. So you do the name of the map, you put map, and now you put the actual data type that you want for your key, then the data type that you want for your value. So I'm going to put integer or int for my key, and then I'll put string for my value. And I'll show how you can mix and match in a moment as well. You use the keyword map of. I need curly brace, the angle brackets here, int, string, and now here is where I actually have my key value pairs. So if I say 1, 2, quotation marks, let's say hello. So this means that if I try and access the value at index 1, we'll get the value hello, which is a string. If I want to put another one, you just put comma and do the same. It doesn't have to be successive, so as in it doesn't have to be 1, 2, 3, 4. I could put 20, for example, 2, and here I could put world, and again it doesn't even have to go up. It could be 5 now. So as you can see, let me just finish this off. Hello world, I'll just put quotation marks here, not quotation, exclamation marks, exclamation point I should say. So as you can see, I've done 125. So there's a lot of flexibility with this, and let me show you how to essentially just print it out. So to print it out, so if I do print line, we can print line by doing map, square brackets, and then we can do the actual key. So if I put 20, run it, and what do we get? We get a value of world, which is stored at 20. So that's pretty cool, pretty simple stuff. Now I want to show you how we can essentially loop over the entire map. If maybe we want to print it all out or go over it for some reason, we can do that with a for loop. So for loop, like so. And what we want to do is for every key in map.keys, so again every key, then what we can do is actually here, I'm pretty sure you can guess, we could either do print line map and then put key here, or we can use the .get method, which is print, or no, print line is just what we're doing with it. The actual key part is map.get, and if I specify the key itself, which is what we retrieved here, we'll print essentially hello, then world, and then the exclamation point. scroll back. Let me increase the size of this a bit. So as you can see, we have all of it printed out and we've essentially looped over it. Okay, so now I want to show you how to create a map with no specifics in terms of the key value pair data types. I'm going to do var, and I'll call this non-generic, because that's what it is. It's the non-generic interface. And for this, you just put equals map of, and now you just start specifying, the key value pairs. So if I put 10 to 5, for example, so 5 is stored at the index 10. Put comma, maybe I'll put hello as the key this time, and I'll say to world, and you can see the picture where I'm going with this. So I won't add any more, but the principle for adding more is the same. And I'll just do a for loop. I'll copy this, and instead of doing .get, I'm just going to do the square brackets just to demonstrate that in a for loop. I'll take this opportunity to demonstrate the different versions, and I'll just do an empty print line here and here, just so we can see where one ends and one starts in our console. So if I run this, okay, so let's see what we get. We get a 5 and world. So now we've used the non-generic interface, and the non-generic interface has essentially allowed us to be able to create key value pairs with no particular data type in mind. I would overall recommend this one, the generic interface, simply because it sort of creates a bit of predictability. You know what you have to be doing. If you want extra flexibility, you do have that non-generic interface. There's a bunch of methods for essentially doing the same thing. We've got the .get for getting a value, but the square brackets for getting a value. You can do .get value as well. There's also a bunch of other methods like .contains, which I think you can get. It checks if it contains a particular index, and there's a bunch of other stuff as well. You can check it contains a key, contains a value, and there's so many functions that you can use. You can use stuff to be adding the elements together. What I'm going to do is, because we've covered the basics of maps in this video, I'm going to provide another link which shows you the extra advanced features of the map collection. But if you have any questions, feel free to pop me a message, and as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming video, I am going to cover the hash map collection. And the hash map collection is built on top of the mutable map interface, which means you can add value, you can get and retrieve. You can retrieve values, and you can also set values as well beyond the actual initial creation of the hash map. It stores the data in the form of key value pairs. The implementation of the hash map class doesn't actually make any guarantees about the order of the data, in terms of the key value and the entries of the collection. So if you want the order to stay, to remain constant, especially if you're looping over it using some sort of iterator or for loop, hash map probably isn't for you. But if you don't, then hash map is a great alternative to some of the other collections. But as usual, experiment, find which one works for you, and then obviously use that one. So if I create a variable, I'm going to call it hmap, short for hash map. And so let's just create one with a key value pair of integer and string, integer being the key, strings being the values. So I'll put colon, hash map, and the first thing is the key data type. So I'm going to put int, comma, string, and now this equals a hash map. Let's put int, comma, string. I really want not on the same line because it's just a little bit. There we go. So this is what we would have as an empty hash map, and then we can add values after. We can do hmap dot put. So this adds something at a particular index. So if I put 1, for example, comma, and I put a word, maybe I'll use superhero name, so Batman, and I'll have a total of 5. So let's say 2, 3, 4, 5. Obviously these don't have to go up like this. 2, 3, 4, 5. This could be 20, and then this could be 15. It's totally up to you. And I'm gonna put Yoda. Some people will disagree that Yoda is not a superhero, but I think he's a good guy. He has superpowers essentially, which is what the Force is. He's a superhero. This is Superman. I'll put Aquaman. The movie was very good. It's looking like it's going to gross over $1 billion, which is great for DC. And another one, I'll put Freedom Yacht. If you are unaware of this character, it is essentially Kryptonite, no, a Daxamite, which is the cousin race of Superman Kryptonians, and he's basically a Green Lantern as well. So it's like Superman with a lantern ring. So let's just say pretty powerful. And I'll print it out now. So I'll just quickly loop over it. So if I do 4. So there's a few ways that we can print it out. So first of all, we can actually just get an individual value. So for the print line, and if I just do hmap, and I put square brackets, and if I put the actual key itself, so 3, it will print out Superman. So for now, I'm just going to comment this line out. Those curly braces won't do anything because there's nothing there. We get Superman printed out. If we want to, loop over all of it, we can do for key in hmap dot key. So we're just getting all the keys at the moment, and this allows us to do some really cool stuff with this. So we can either use a dot get method, or we can use a square bracket and put the key in there. I'll use the dot get method just so I can show you the different implementations, and therefore you can choose which way you want to go. Save that, and if I run it now, there we go. I'm not even printing it out. I'm literally just retrieving it but not doing anything with it. So let's rerun it. So we get all of the value printed. So we get Batman, Yoda, Superman, Aquaman, and Sodom Yacht. You can also create a hash map. So var, I'll call it hmap2 with an initial sort of size. So I'll actually copy this. So of course hmap2, and if at the end here, we have the brackets, if we put, let's say 2 for example, this means it has a capacity of 2. So now let me it doesn't mean this capacity is fixed, it just means the initial capacity is set. You might be thinking, why would you want to do that? The reason is, if you know that you're going to have, let's say, a minimum of 2 items in there, you set the initial capacity to 2. That way it's reserved the memory, and you won't have any unforeseen circumstances, maybe if you're short on memory on that system, but you could add more data later. So that's like the use case, and I'm going to leave this up to you to add data to it. It's literally just the same as this, just the name of the hash map dot put, the actual index or the key name, which is in this case an integer, and then the string value or whatever data type you've chosen. So you can also do stuff like dot remove as well. So if you want to remove values, you can remove them by, well, you can either replace a value, you can go down that route. So if I do, actually, you know what? I think I've already shown you quite a bit in this video, because removing and putting values are essentially, very similar. You use a dot replace method, it allows you to replace a particular value at a certain index. You can use methods called contains key and contains value, which allow you to check if it contains a particular key or a particular value. You can use dot clear, which just empties out the actual hash map itself. But if you understand everything that we've done in this video, you're all good to go. But what I'm going to do, I'm going to sort you out. I'm going to provide you with a link that shows you all of the hash map features. So I'd recommend that you go through them. But if you have any questions, feel free to put me a message. I really highly recommend it. Reach out. I'll assist you. And as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming video, we are going to look at the hash map of function, which allows you to create a hash map, but you need to assign values, key and value pairs from the start. If you don't know what a hash map is, don't worry, I've created a video covering the basics of that. I recommend checking that out, then come back here. Okay, so I'm guessing you've checked that out. We're all good to go. So if I create a hash map, I'll call it hash map, and I'll put colon hash map, and I need to specify the actual key value data type. So if I put integer, string, so string must be a capital S. This just means that the keys come in the form of integers, the values come in the form of strings. And I'll put equals hash map of, and specify it here, so int string, and now I'll specify the actual values, and the key value pair. So if I put 10 for example, then I'll put the keyword 2, and this just says the actual value is, and I'll say hello, then I'll put comma, then I'll put the next key. I could put 5, it doesn't have to go up, it doesn't have to go up in 1, it could be, as long as it satisfies this condition of being an integer, it's okay. And I'll put 2, and I could put world, and I'll put one more, maybe 100, 2, and I'll put my name, so Shahan. Comma, semicolon, that's not a comma at all. And now what we will do is we'll print it out. So we'll just do a simple for loop. Again, if some of this seems alien to you, have a look at the hash map video, and it will, it explains everything basically. So if I say for every key in hmap.key, so this is just getting all the keys. Now from here we can essentially get all of the values, and you can get the values however you want, using square brackets or using the .get method. Again, feel free to look at the hash map video for more information, and I will provide a link with even extra information as well, so you can get the most out of the Kotlin programming experience. And here I'll put key, so this will retrieve the value, but it's not doing anything. Let's put it into a print line, therefore it will print it out and we'll be able to visually see it. So for home world hello, as you can see, it's printed it out, and if you look, it is in a slightly different order. The thing with hash map is the order is not guaranteed, so it is in a slightly different order. That's something to bear in mind. There's a bunch of other methods, like if it contains a particular key, contains a particular value, contains a particular key value pair, you can replace stuff as well. So I'll quickly demonstrate the replace method. So if I put, first of all, I'll put print line here, just an empty one, because I'm going to reprint this out. I'll do that right now actually. I'm going to reprint it out, but here I'm going to replace one of the values. So I'm going to say hmap dot replace, and if I put 10 for example, so I'm replacing the value at the index 10, and I'll just say replaced. I'm going to say pizza. So I'm just about to have some pizza after I've recorded this video. And now if we run it. So as you can see, instead of the string hello, we now have pizza. So that method dot replace allows us to simply replace values. So really simple stuff. You can use get value to be able to get a particular value instead of using the square brackets. You can use the dot get method. You can use dot remove as well, which allows you to remove a particular key from it, and as a result that removes the value as well. But like I said, there's so many methods that I'll provide a link so you can see all the extra features that are provided via Kotlin. If you have any questions, feel free to pop me a message, and as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming video, we are going to look at the mutable map interface. And the mutable map interface is essentially a collection framework that allows you to hold objects, in the values of key and value pairs. A lot of the other collections, such as the hash map collection, is built on top of this interface, but you can create collections directly using this interface, and that's what I'm going to show you in this video. So I'll create a simple one. I'll call it mmap, so for mutable map, and I'll put colon. I'll put mutable map, and now I need to specify the key and value data types. So I'm going to say the data type for the key is going to be an integer, and the data type for the value is going to be a string, but you can mix and match. It's totally up to you. I'm going to say equals mutable map of, and this mutable map of, so this is just going to have data types of int and string as we've already specified over here. It needs to be the same, and now we need to specify the the initial values. So we are going to say 10 to, I'll say from on, and I'll put 20, and I'll put my surname, which is Hussein. Okay, so we can print this out using a for loop. You might be thinking, only two key value pairs, does it warrant a for loop? And not necessarily, but I want to demonstrate how to use a for loop, and it doesn't matter whether you have 2 key value pairs or 200 key value pairs, and it will just work. So actually, just to print out one, if you just know you want a particular one, you just do print line, or to access one, whether you print it out, store in a database, totally up to you. Do mmap dot get, then the actual key itself, so I'll put 10, and that gets it. You could also use square brackets to retrieve the value, which is what I'm going to show you in the for loop. I'm going to put an empty print line so we can see where it starts and ends of the different sections for printing it. And to be able to get all of the values, we do for key in, so we're getting all the keys, and that in turn will allow us to retrieve all the values. So we'll do print line mmap and put square brackets, and now if I put this right here, key, what's that moaning about? It is moaning about it's moaning about something. Oh, dot keys. I need to do dot keys to be able to get the keys itself. Okay, I was wondering. I tried it before recording, and it worked fine. There we go. We're able to print out an individual value, but also being able to print out all of them using a for loop. We can use the dot put method to add values as well. So you will just do mmap dot put, and then the actual key value pair. You can use contains methods, which allows you to check if it contains a particular key or value. I've shown you the .get method. The .get value is the same, but it's just named differently. You can use the .count method, which I think you know what that does. It's a pretty simple one. But as an extra task, I want you to have a look and try and use all of these functions that I'm talking to you about. But what I'm going to do is provide a link that shows you all of these features plus many more that you can experiment with. But if you have any questions, feel free to pop me a message, and as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming video, I am going to show you the set interface. The set interface is a normal generic collection of elements that are unordered. You cannot have duplicate elements, and it's immutable, which means it's only for reading. You can't write to it beyond the initial creation, but you have to specify the set of values that you want to store. So if I create a set, I call it set1 equals set of, and now you specify your values. So if I say 1, 2, 3, 4, 5, 6, 7, and 8, the data type has been inferred based on the values, which is an integer. We can print over this using a for loop. So it's going to say for every item in set1. So this basically just gets every item, and we can just print it out. So print line item. So let's run it, see what we get. So we get 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's pretty cool. We can also create a set and specify the data type. To do that, we do var set1, set2, let's say equals. Actually, here we need to put colon. Now we put set angle brackets. In here we put the data type. So if I put string equals set of, and if I try and put 3 in there, we get an error. It says required string, but we're getting an integer. Whereas if I put, let's say hello, that is a string. If I put world, and if I were to put this, even though it looks like a number to us, because it's got quotation marks around it, it is technically a string, and the printing out is exactly the same. You use this for loop right here. As an extra task, I'm going to leave that to you. Let me show you how to create a set that where you can mix and match the data type. We do set any equals set of, and so if we put 1, 2, then maybe I'll put my name in text form, and I put the value true. We can mix and match the values. Again, you can loop over it the exact same way as you have done before. And as an extra task, I recommend that you do that. So maybe you want to check if the set has a particular value. So we want to say, so if we do print line. So maybe we want to check if set3 has the value 1, this one here. So if we do, you do the name of the set, so set3 contains, and in here, let's say if I put, well, I'll put 2, but that is in there, so that is fine, and we get true. If I put 4, for example, 4 is not in this set, therefore we will get a value of false. There we go, we get a value of false. You can also use a method called contains all, which allows you to essentially check if it contains a set of values. And what you could do is, let's say set3 contains all, and the parameter that you could provide is another set. So maybe if you have a larger set of information and you have smaller subsets, you're seeing if it contains that particular set. There is methods for checking if it's empty and if it's not empty. I'll provide a link so you can see all of the extra functionality for set collection containers. But if you understand everything that we covered in this video, you'll be all good to go. As usual, thank you for watching, and I look forward to seeing you in the next video. Hello, in this Kotlin programming video, I am going to show you how to create a mutable set. So remember, a set is a generic sort of collection of elements that are unordered. They cannot contain duplicate elements, but by nature they are immutable, which means you can only read to it. A mutable set is one where you can read and write to it as well. So to create one, it's pretty simple. Actually, I recommend that you look at the set video first because it'll really help with what we're doing here. Okay, so if we create, a set, so we call it set1 equals mutable set of, and we specify the data type. So let's say if I specify int, for example, so int int, and if I do 1, 2, 3, 4, 5, 6, and if I were to do a for loop, and I'll do for every item in set1, I'll just print out the item. So that's just going to print out every single number in our set. This could be the any data type, it could be the string data type, any data type that you want. Okay, so we get every value printed out. So how do we actually add data to it after initializing our mutable set? It's actually really simple. Name the set, so set1 dot add from the value. If I do 10, for example, maybe do 108, just fancy a larger number, and I'm gonna copy this. So it's gonna print it out again. I'm just going to do an empty print line just so there's a visual gap between the two for loop printouts. So if we have a look, 1, 2, 3, 4, 5, 6, then 1, 2, 3, 4, 5, 6, 108. So it's added an extra item. You can also use a method called add all, which allows you to essentially get another set and add the contents of that set to this particular set. I'm going to provide a link so you can see more information about that, but it's really, really simple. You can also remove elements as well. So if we say, if I say set1 dot remove, again, there's a bunch of different remove methods. There's methods for checking if it contained a particular element, if it's empty, getting the first value, getting the indexes, dropping data from it, all of that. But if you understand everything that I'm covering in this video, you'll be all good to go. And I will provide an extra link so you can, see all of the extra functionality. So if we just want to remove something, say if we want to remove the value 2, and we do, I'll just do this print out again. And now if I run it, see what we get. So we get 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 108. Now on here, 2 has been removed. So the value 2, it goes in there, finds that value, and then it removes that value. So simple stuff. The set is really useful if you just want a simple collection of data. If you have any questions, feel free to pop me a message, and as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming video, I am going to show you the hash set collection, which allows you to store data. It stores data using hashing mechanism. It supports both read and write, functionality. It doesn't support duplicate values, and it actually makes no guarantees about the order of the elements as well. You'll store the elements, but there's no guarantee. So if you want like the guarantee that when you add the elements, they'll be in the particular order that you've added them, for example, then this is not the one for you. This isn't what you want. So let me demonstrate how to make this. Pretty simple. If I call this set1, I'll just set equals hash set, and in between the angle brackets you put the data type, basically the sort of data that your hash set can store. So I'm going to put int, you can put string, you can put any, and then you put open close bracket. Now you specify the actual amount of values. So if I say 10, for example. So that's the initial capacity. Basically, it reserves that much memory for it. And if I do set dot add, we can add the elements. So if I just do 1, and I'll duplicate this so there's 4, 5, 6, 7, 8, 9, and 10. And I'll literally just do 1, 2, 3. Ooh, did not want to do that. 4, 5, 6, 7, 8, 9, and 10. Okay, so let's print all of this out. So if we create a simple for loop, that just gets every single item from the set. If we got the keyword on, I will put that now. And now if we do print line, item, and now if we run it, let's see what we get. So we get, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's actually in order this time, but sometimes it isn't. I recommend as an extra task that you try to do more generic hash sets as well, where you specify the values at the start. If you don't know how to do that, I recommend looking at the other videos in the collection series of this course, and you'll understand how to do that. Basically just all of that. So I've covered add method. You can use a method called add all, which allows you to add another set to to this set. For example, you can use a method called dot size. So let me show you this. If I do print line item dot size, not item, set dot size. Let's run it now. So we get 10 because it's of size 10. You can also print out, or just get, you don't have to print it out. What you do with it is totally up to you. You can check if it contains a particular value. So for the set dot contains, and maybe I'm checking if it contains the value 4. Let's see what we get. We get true because it does. 1, 2, 3, 4. We don't have the value like 11, so if I put 11 in here, we get false because 11 is not in there. You can also use methods for removing a whole set, a whole another set from another set. You can use methods for checking if it's empty, not empty. All simple stuff if you understand what I've covered in this video. If you have any questions though, feel free to pop me a message. I'll provide a link to the extra features for hash sets. And as usual, I look forward to seeing you in the next tutorial. Hello, in this Kotlin programming video, I am going to show you a basic example of a class and an object. So Kotlin, like many other languages, supports object-oriented programming, so OOP, as well as functional programming. So object-oriented programming is based on essentially like the concept of real, objects and classes, real-time objects and classes. So for example, you're a car company, you make a car, you don't start from scratch every single time. You have like an overall layer that's 4 wheels, and I guess some variants, but let's just say 4 wheels, X amount of doors, X amount of seats, it's gonna have an engine, it's gonna be able to accelerate, decelerate, it's gonna have this. You don't start again and again. You essentially use a template, you make any little modifications to make it unique to what you want it for, but that's it. And that's what a class is. So a class, implementing a class is really simple. Outside of the main method, so before it, if we put the keyword class, now you name your class. So I'm going to call this car, and you put curly braces. In here, you put any variables that your class has and any functions. So let's start off with the variables. So I'm going to say var, and I'm going to say speed, and this is going to be an integer. So the speed is actually, I'll call this current speed, for example, current speed. This is an integer, and I'll initially set this as to 0. I'll say max speed is also an integer. I'll set this to 120. So yeah, the max speed of 120. I'll do var model, and this is going to be a string, and by default it'll just be an empty value, and that's it. You can go further and add more, parameters, more, information that you need, but this will suffice for what we need. So we're going to create some functions in here. So you put the keyword fun, then obviously you just create your function the normal way. So we're going to say, change model. We'll call it set model, and we're going to pass in a model name. So we're going to call it M. And what is this moaning about? There we go. We're going to say model equals M. We are going to do fun set current speed. So we're just creating some basic setter methods, and we are going to say we're going to pass in speed, which is going to be an integer. Now we are going to say current speed equals speed. We're going to copy this because the max speed method will essentially be the same, just named differently. So set max speed, and we are setting, well, the max speed here. Okay, so that's pretty simple stuff. We'll go in more depth on different actual classes and the sort of different stuff you can do with them, but I'm just going to keep it simple for now. And if I create some of these, so now we're going to create some objects. An object is just like a variable of a class. So these are all variables. So if I say var, I'll call it car1 equals, and now you put the class name, which was car, open close bracket, and that's created. So if I do car1 dot, let's say if I do car1 dot what methods have we got? We have dot set model, and for the model I'm just going to put a manufacturer, so BMW, and I'll do car1 dot set max speed, and this is a very slow BMW at just 20, and we're going to print these values out. We're going to do print out car1 oh, what am I doing? I meant to print out the values, not the actual object. Car1 dot speed dot max speed, and I want to print out car1 dot model. Okay, so we get BMW, we get 20. My thinking, what's the benefit of this? Can we not just create a bunch of variables like this outside and save the hassle of having these methods? Yes, but now this is where it's going to be really cool. Maybe we're creating a game. We have multiple cars, so let's call this car2 equals car. And I'm going to do the same thing here. So print out car2's model and speed, but I'm not going to set the model and the max speed for car2. And let's see what we get. As you can see, we get BMW, we get 20, which is the model and the max speed for car1. Car2 has no model because by default it is an empty string, and car2 has a max speed, which is the default max speed, which is set to 220. So this is the benefit of it. They have their own unique properties. So any changes we make to car1 don't affect car2, and vice versa. So we could have 100 of these objects. It's like having variables. Why have one integer variable when we can have a million? No, I'm just joking. You always want to reduce the amount that you can have. But to make things easy, why have one variable to store everything and you're constantly trying to figure out, are you going to be overwriting something that you need later? When you can have a few extra variables, one variable might store one piece of data, another variable might store another piece of data. That's the benefit of classes and objects. Like I said, this is just the intro to a basic class and object example. I am going to cover a lot more, from visibility to inheritance to constructors, to all of that good stuff, to really get your object-oriented programming game through the roof. So that's it. If you have any questions, feel free to pop me a message, and as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming video, we are going to continue with classes. We are going to look at the nested and inner class functionality. So this does build on top of the basic example that I created in the basic example video. So I recommend that you follow along with that. That's the same with pretty much all of the classes and objects part of this series. A lot of it is based on the previous videos. Make sure you follow along. If you already know about classes and you're just quickly popping in to learn about nested and inner class, that's fine as well. That's fine. Okay, so what is a nested class? Just like the way you would nest maybe a loop. It's just a loop inside of a loop, just a class inside of a class. So the overall format is like this. So if I create a class, what happened there? No, that's fine. If I create a class here, like class, and I'll call it wheel, for example. So like the car and the wheel class inside of it. The format is pretty much the same. Inside of here you can have variables. So if I have a variable, I'll have, what should I have? var, and I'll just say, I'll call this test var. I just want to show you. Okay, so the data type has been inferred based on the fact that it is a integer that has been assigned to it. You can have a function, so fun epic func, and this function, all I'm going to make it do is print something out. So all I'm going to make it do is print line test var. So if I save that, to actually access that from one of our objects, you would just do, so I'm just going to comment these lines out just so you know the way. You do like car1, for example, dot, and what was the class called? It's called wheel. Was it called wheel? It's called wheel. So dot, sorry, I was about to burp them. Dot wheel, so dot wheel, and you should do that like so. Dot, and the actual method was called epic func. Okay, unresolved reference to wheel. What is it saying? So let's have a look. What's it saying? Yeah, that's fine. That's fine. So we get class wheel, class wheel, var test var. So far, I'm not really seeing any problems. Function epic func. No, actually, I'm seeing the problem. Sorry. I forgot to mention, these inner and nested classes are static. And what that means is they aren't created. They're just like a normal function almost. You don't have multiple instances of it. So car1 doesn't have a separate, sort of instance of it compared to car2. So to actually run it, you just do the name of the class, the outer class. The outer class will be this one here, so car dot wheel, so the name of the inner class, and you put brackets here, so this knows that you're calling the actual object. You could assign this to something, so I'll show you that in a sec. And then we can do dot epic func, and if I were to run this, we get 8, okay, and that's because that's assigned 8. And like I said, what you can do instead, if you know you're going to be using the inner class a lot, you could do var, let's just say wh short for wheel equals car.wheel, and that's it. So everywhere that we need to use car.wheel, we just use wh, and this gives us the same result, but it's just a nice shorthand, neater way of doing it. So one last thing that I want to show you is that because it's static, this cannot access the variables from the outside. So in here, if I were to try and do print out max speed, so if I do print line max speed, as you can see, we are getting an error. And if we have a look at it, unresolved reference. So we are unable to access the outer variables. To do that, we need what's called an inner class, and you put the keyword inner here, and you're able to access them now. It's that simple. So that's all I wanted to show you, how to nest a class inside of a class. It's pretty unique to Kotlin. Most programming languages don't let you do this. You're probably honestly not going to, doing it all the time, but it is some pretty cool functionality nonetheless. Pretty simple, but if you have any questions, because when you start nesting stuff, it can, I'll say theoretically get complex. Feel free to pop me a message and I will assist you. And as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming video, we are going to cover constructors. So if you haven't done the basic example project for classes and objects, I highly recommend doing so. This is going to be building on top of that. So what's a constructor? The constructor is something that is run when you create an object of that class. As you can see, we've created two objects of it. Maybe you want to do some initial setup, and constructors are a great way of going about that. So to set up a constructor, there's actually a few different ways. Kotlin has a few unique ways which you won't see in most languages, so I'll cover them so you can choose which one you want. So you put the keyword in it, which is short for initialize, some curly braces, so it's like a function, and here you do any setup. And I'm just going to show you a print line first. I'm going to say hello. Hello there. And if I were to scroll down, I'll uncomment these out. And as you can see, the first thing that is printed out is the car model in terms of the main. But what you'll see is when we run it, hello there, it's printed out twice because we've created two instances of this. So when this object is created, it calls the init method. So that is really useful if you want to do some initial setup. And some of the setup that you might do is, instead of having these variables like there, you would have something like that here. You would get rid of this, get rid of this, get rid of this, and this. So here, the only thing you would have is the data type, like specifying the variable and the data type. And you do all your setup here, and that still works the same way. Also, if you're doing some more complex setup, maybe you're doing some checks, potentially this is linked to a database, you could do the linkage in here, get some information. Maybe there's some defaults in the database and they would be stored into the variables. So this is what the init method is. You can use something else as well. So this is what you would call a primary constructor. You can use a secondary constructor as well. So let me show you how to use a secondary constructor. And this will look more familiar to other constructors in other programming languages. So you use the keyword constructor, open close brackets, and in here, again, we can do stuff like, let's say, print line, let's say secondary constructor. And if I run it, let's see what we get. I realize I've spelled secondary wrong. Scroll up, as you can see, first the init method is always called. That's the primary constructor. Then the constructor for each object that is created. So this line calls the init, and then it calls the constructor method as well. And the same for this one. Okay, the great thing about this one is, as you can see, there's brackets here, so we can pass in variables as you normally would with any other method. So maybe we have a variable for, maybe you have to specify the model, you have to specify it, and we would do, let's say, colon string, and then in here you would do model equals m. And here, as you see, we've got a red squiggly line because this is saying this method here, these open close brackets are calling the constructor. If you're wondering how was it working when we didn't have a constructor implemented, if you don't have one implemented, the compiler adds one, like a default empty one anyway. So that's essentially the way it was still working. So here, if I add, some sort of model. I'll say what is it? Honda over here, or I'll put Toyota. And now if I were to run it, as you can see, this one says BMW because it's been overridden here, but car 2 model was never overwritten, so it still has Toyota. That's when the secondary or the secondar constructor was called. So this is great if you want to pass in some default values. You have to just do one variable as an extra task. Modify this so it accepts multiple variables, maybe one for current speed, maximum speed, and model, and assigns them. So if you want something quick and easy, the init method is great. If you want something a bit more complex, then the constructor is the way to go, and that's the secondary constructor. So that's it for this video. If you have any questions, feel free to pop me a message, and as usual, I look forward to seeing you in the next video. Actually, I'm going to change this. There we go. See you soon. Hello, in this programming video, I am going to show you visibility modifiers in classes and objects. So we are building on top of the previous videos that we've done in the classes and objects part of the series. I recommend checking those out first. Okay, so what's a visibility modifier? So you know how we have these functions and we have these variables. They have basically a visibility range. And there's 4 ranges. And the 4 ranges are private, there's protected, there's internal, and then there's public. So what this means is, and I'll show you how to set them as well. If your variables or your functions private, that means it can only be used within this class. You cannot call it outside of the class or from a child class. I'm going to be covering child classes in the inheritance part of this, series, which is very soon. And then internal. Basically, any client inside this module who sees the declaring class, sees its internal members, and public, anyone can see it. So child classes can see it, this class can access it, and the objects can access it as well. So let me show you. So if I make this one private, so you just put the keyword private in front of it, and that's the same with functions as well. I'm just going to demonstrate it for variables, but you can do it for pretty much anything. As an extra task, I recommend experimenting with the others. So I'll do public, and like the others, I'll be explaining more when we get on to what's it called, inheritance. So what's this saying? This is saying redundant visibility modifier. So that's very interesting. And if we scroll down, and if I were to try and do, as you can see, we're able to print out model and print out max speed, not as we normally were. So the reason it's saying redundant is because by default your parameters of your class are set to public, meaning they can be accessed anywhere. But what happens if I try and do a print line here, print line, and I'll get one of the car objects, and I'll do .current. As you can see, it doesn't even come up. It says cannot access current speed, it is private in car. That means we cannot access it outside of this class. It can only be accessed within inside. You might be thinking, okay, 1, how would he get hold of it? And 2, why would he do this? The way you would get hold of it is using a getter method. And we've got setters, and the get method, instead of taking a variable in, it just returns that variable out. So let me just quickly demonstrate that for fun. Get current speed, and we would do return return current speed. What's it missing? This one is missing. Yeah, there we go. Okay, so now if we want to actually get it, we do get current speed, and now if we run it, that gets the current speed. Okay, so that solves that. Again, my thinking is that even necessary? Isn't that a bit cumbersome? So print the LT as 0, so that's the current speed. And the main reason you do this is for protection purposes, because when you're on a larger project, you have multiple developers. You don't want somebody to accidentally be able to do like car1.current speed and modify the value. if you have to have setter methods for setting the current speed, if they provide a value that's invalid, so for example, maybe the current speed has a range between 0 and the max speed, but if you try and set it here, you could just directly set it. Whereas if it's setting set current speed, we could do a little check saying if speed is greater than or equal to 0, and if speed is less than or equal to max speed. What's this? Yeah, fine. And only then will we actually assign it. If it's basically within this range. What's this mode about? No, it's double amp, so I don't know what's happening now. I forgot there's a range check that you can do, but that's fine, that's fine. Okay, so what we've done now is when we're setting it via the setter method, we're basically checking if it's, a valid range. Maybe it's a bit more even complex than that, and they're taking, some data and it needs to be manipulated somewhere. So not just some sort of condition needs to be checked, but it needs to be manipulated. Only then it gets assigned. So that's the beauty of making stuff private. It prevents accidental modification. It forces you to use getters and setters if you want to access the value for read or write purposes, and therefore you can add conditions to prevent any mistakes from occurring. So I recommend making all things private. For testing purposes, public is alright, but I would say private, it'll save you a lot of hassle down the road. So that's it really for visibility modifiers. Like I said, on the cover protected in the inheritance part. Feel free to check that out, and as usual, I look forward to seeing you in the next video. Hello, in this programming video, I am going to show you inheritance in terms of classes and objects in Kotlin. Okay, so inheritance, essentially all it does is it allows you to create sort of like a base parent class. Then you can have classes that inherit from this particular class. So instead of calling this car, I'm going to call this vehicle, and I just need to make a few modifications, mainly this vehicle. And the reason I'm just doing that, because you could have a vehicle, and then based on that you can inherit from it, and like have a car class, have a bike class. So outside of this class, after it, you put class, then the name of your new class. So I'm going to call this one car, then you put colon. Now you put the base class that you want to inherit from. So it's called vehicle, open close bracket, and we'll get an error. So this error is saying this type is final, so it cannot be inherited from. So by default it is final, therefore you cannot inherit from it. And you have to put the keyword open in front of your base class. And as you can see, and also as you can see, this requires a default parameter as well. So we're actually going to get rid of that. It's pretty simple to add it there, and when you call its sub method, you need to call that as well. I'll leave that as an extra task for you to check out, but I just want to keep it simple. And as you can see, we got this right here. You can create variables. So if I create a quick variable, I'll say test var equals hello world, and I'm going to create a function. So function test, again just for test purposes. I'm going to put print line yay. So now if we want to create an object of this class, it's pretty simple. It's the same sort of method. You just do var. So I'll call this v1 and v2. So the vehicles essentially, and not cars. Okay, this should be, yeah, that's fine. And I really should update these as well, to be fair. Just because this code will be part of the source code, and I don't want to uncomment it and it's not working. So I'm going to create a car equals car, like so. So what this means is if I do car.test, we run that, it will call this test method right here, and it will say yay. But as you can see, the constructors, So I'm actually going to comment these lines out, otherwise it's getting a bit confusing of what's happening. So as you can see, the primary and secondary constructors of this class were called. Even though we didn't create an object of this class anymore, the only object we created was of the car class. But remember, this is inheriting from the vehicle class, so he gets all of his properties, including the constructors. We can also do this, because it's got all of his properties, we could do car dot, and we can get, the speed variables, the model, we can get the current speed, we could set the speed, we can essentially get everything. So if I do get current speed and I, let's say I'll put that in a print line, we can do that, get all of the properties of the parent class. And that's it. That's all a child class is. I'll cover more advanced stuff for inheritance in the subsequent videos. Feel free to check them out. One last thing I want to show you is visibility scope. So I mentioned protected in the visibility modifiers video. So if I make this one protected, so what that means is it's private, but it can be used by children class as well. So if you look, this one's private, this one is current speed. If I go to a child class and in here I try and do current speed equals 9, for example, that don't work. If we go to it, it says it is invisible, it is private in the vehicle class. Whereas if I try and do, what's the other one? Protected was model. So instead, if I try and do model, as you can see it appears, and we try and assign something to it, like model for example, that works fine. We still cannot access it outside of it because it is private in terms of outside access, but that's the difference between protected and private variables. Private or properties can only be used within the class that they are declared in. Protected can be used within the class they are declared in and any children class that are inheriting from it. That's it. If you have any questions, feel free to pop me a message. And as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming video, I am going to demonstrate method overriding. So we've got a couple of classes. We've got the base class, and then we've got this class that inherits from the base class. And this child class here can use all of the properties from this class. Anything that's public or protected, that is, obviously the private ones you can't. Okay, so we have these methods here. It can use these. You might have, for example, a parent class, then several children class, and some of the children class use the method in the exact same way, but some of them want to override the functionality, and you can do this really simple. So imagine for the set max speed, instead of doing that, what we want to do, and to override it, you go to the child class where you want to have slightly different functionality for the function with the same name, but the keyword override, then you just create a function, and it was called set speed of the set max speed, and it takes, see, it's moaning at the moment, and that's because it's overriding nothing, because we haven't specified the parameter. It has to be in the exact same format. So it was speed colon int. That will now disappear. No. Sorry. You also have to put the keyword open here. That way it's not final and it can be overridden. Okay, let's remove that error. Imagine in here, instead of doing max speed equals speed, maybe we want to do some calculation. Maybe it has to be divided by 2. Again, a simple example, but this, and if we go to here now and we print out car dot get, yeah, max speed is already a public variable anyway, so we can access it directly. So if we print this out now, still, oh, we haven't set it. We need to set it. So that's the max speed. If we don't set it, it's a default of 120. We've initialized it. And if we were to do car dot dot set max speed, and we'll set this to say 190. So we'll divide it by 2, which will give us 95, and we'll print it out again so you can see the difference. As you can see, we get 95. I'll go one step further, and for starters, I want to get rid of this. No, I'll leave this in. I'll leave that in there. I'm going to go a step further and just do a print line. So print line, I'll say overridden method, and for this one, I'm going to say print line parent method. Now, if we run it, as you can, I'll put method instead of method, but same thing. There we go. So as you can see, it went to the overridden method in the child class instead of going to the parent method. If we have another class that inherits from our vehicle and we don't override that method, you'll use the functionality from the parent class. So that's an example of how to override methods and where you would want to. So that's it, pretty simple. If you have any questions, feel free to pop me a message. And as usual, I look forward to seeing you in the next video. Hello, in this video, I'm going to show you property overriding. If you haven't watched the method overriding video, highly recommend that you check that out first. So property overriding, so we have this property, here. It's, the public and protected. So I'll just deal with the public one, max speed. So imagine if we have max speed like that, and imagine if we here even set a value of 100, for example. This will essentially get overridden by this anyway, but I'll comment this out for demonstration purposes. So we've got a max speed here. Imagine if we essentially want to create another one of these but in the child class. So we could obviously here do max speed equals around 90, whatever the value is. But if we wanted to do it here, we wanted to do var max speed colon int equals 90, for example, you'll give us an error. It's saying max speed hides member of super type vehicle and needs override identifier. So we first of all need to put override here. So we are saying that we are overriding it. And next, because it's final, we need to make it open. So if we go to our variable to start, we put keyword open, and you can see you get no errors and it's being overridden. So if you want to override it here and you don't want to put it within maybe another function or even its constructor, you want to put it here, that's how you do it. You have to do property overriding. Pretty simple, but if you have any questions, feel free to pop me a message, and as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming video, we are going to cover abstract classes. So we, covered the interface before, right here, which allows you to inherit. So we've got this open class vehicle as well. We have this class which inherits from the other class. And we can create an object of the car. We can create an object of vehicle as well. So if we were to do var vehicle equals vehicle, I'll call it VEH just to prevent any confusion, and then I could do VEH, call one of the methods like hello, for example, run it, and it will do whatever hello does, which is it says hello there. As you can see, it has run, and obviously so has the primary and secondary constructor. Okay, so all pretty simple stuff, but you may want to have a class that other classes inherit from, but you do not want to make it so it can, so you can create objects of that class. So you purely want it as a class so other classes can inherit from it. That's it. You do not want anyone to create objects of it. And to do that, it's really simple. You just, instead of the keyword open, you put the keyword abstract. Gotta spell it correctly, obviously. Abstract. Now if I scroll down, as you can see, again, it says cannot create an instance of an abstract class, and that's it. If we remove that, now run it, this works fine, but it means that we cannot create an instance of it. Let me just show you something else. So if you don't provide the keyword abstract, it by default is not abstract. And so if for this, for example, I put abstract here, so you cannot have it so it has an implementation. You will need to overload it in this class right here, and I'm going to leave that as an extra task for you to experiment with that. But that's essentially what an abstract class is, just a class that can not have any objects created of it. It's purely for inheritance. That's it. If you have any questions though, feel free to pop me a message, and as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming video, I am going to show you how to call a overridden method, like the original sort of super method from the parent class. So we've got I want to create a whole new method. So I'm going to create a method that we're going to override. So open fun, I'm call it hello, and all it's going to do is print line, and it's going to say hello there. And if I were to call this, so I will comment out everything else just so it's easy to see, and I'll say car dot hello, and if we run this, it says hello there. Obviously we've got the constructors calling the primary and secondary, but we can ignore them. So hello there. If we were to override it as we've done before, if you haven't checked out the overriding methods video, I highly recommend you do. So we are overriding the hello method, and in here we are doing print line, I'll say hello world instead. If I run that now, as you can see, what we get in the console is hello world, even though the function call has stayed the same, this part has stayed the same. So we overrid this method, or overrid this one with this one, it calls this now. But maybe we need to, call this one, but from here we need to call the original one as well. We need its functionality as well. You can do that pretty simply. So if in this method, anywhere here, you do super dot hello and run it, as you can see, we get hello world and hello there. So the super class, this super keyword, allows you to call the parent method, the base method that this method inherited from. So that's it. Nothing more to it than that. But if you have any questions, feel free to pop me a message. And as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming video, I am going to show you how to create a data class. So a data class is a class which is purely designed to store data. So we can create one here, no, it goes outside. It should go over here. So I'm going to say, what you do is you use the keyword data, then you put class and the class name. So I'm going to just call it epic class. You put open close bracket, and then you put essentially the data that you want to store. So you put keyword var, then the variable name. So I'll call it, I don't know, str, and this will be a string. And you could, let's say, create an integer, and I'll call it int, and that's it. I'll keep it that simple. And to create it, we just do var, and then we name it. So I'll just call it epic equals the name of the class, so epic class. Now you provide the parameters, so a string and an int, but again it could just have one parameter, essentially one data that is storing. Could have 3, could have 4, could have as many as you want. I'm going to say Batman, and I'm going to say 30 for the number. So if we were to print these out, let's see what we get. Okay, so we got the data right here. If we want to access an individual, piece of data from it, we do epic dot, then I, for example, and there we go. We can run this now. It's not what I wanted to do. I wanted to run it, and we'll get a result of 30 because the I variable is 30. And we can obviously create multiple, versions of these, multiple objects as we would with any variable type or class. Very powerful because it essentially allows us, maybe this is to do with, I don't know, a car, and it's all the properties of a car, the name, the position, the model number, its max speed, that sort of stuff. Really, really useful. If you want to modify the value, do like epic.i equals 78, and then we can do a print line, epic.i, keep pressing Command I instead of Controller to run it. And if you wait for that, as you can see, we get 78 printed. So that's how you modify. And the last thing I want to show you is default and named arguments in the data class. So we can have a default value. So we could say string by default. We're going to be very imaginative and say it's going to be default. And the value by default will be 10. So if I create another variable, var epic2 equals epic class, as you can see, we don't get any errors. That is because we have default values. And if we run it, actually this won't do anything. I want to print it out actually. So I'm actually going to comment these lines of code. I'm going to do print line epic2 . As you can see, it has default values and the original one had the modified values. If you only want to, let's say, specify one of the values, so instead of epic class, we want to do, let's say, we only want to modify the integer, so that is the second variable, but the name of it, which is I, equals then the value. So let's say if I put 55, and now if I run it, we'll get the default value for string, which is default, and we'll get 55 for I. As you can see, that's how you do default arguments, and when we want to select a specific one, we use named arguments. So that's it for the data class. If you have any questions, feel free to pop me a message, and as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming video, I am going to cover inheritance but from multiple classes. So we've already got a simple example where we inherit the car class, inherits from the vehicle class. If you don't know what's happening here, I recommend that you go and check out the inheritance video and the subsequent videos which expand on that with videos for method overriding, property overriding, etc. Okay, you can't unfortunately just do this. So imagine if I wanted to create a new method, new class, and I'll do open class, I'll call it epic class. The name and the functionality for now is irrelevant, and I'll say fun for the function, and I'll say epic fun, and I'll do a print line, for example. I'll say epic fun. Okay. If I want to inherit from it, the way you inherit multiple classes, essentially doing comma, and then you put epic class. As you see, we get an error. It says only one class may appear in the supertype list. If I were to put that as the first one, that's fine. Obviously, we get errors here because we can't find the properties. But if you just look at this line here, it's okay. So the way we get around that is very similar to the way it is in Java. So if you come from Java background, you're going to feel really familiar, you essentially have to create an interface. So instead of open class, you create an interface where this is basically used for inheritance purposes. And now we've got an interface. That's it. Like inside of it, you just create it as you would like a normal class. Now, here if you put comma and we put epic class, but you don't put open close bracket, that'll give an error because you won't have a constructor. And now here we can do car.epicFun, which was part of the interface that we just created. There we go. It says epic fun, and that was from this interface. So that's how you essentially inherit from multiple classes. You need to have an interface. A class can only inherit from a single, normal class, but you can inherit from as many interfaces as it wants. So that's how you do multiple inheritance. If you have any questions, because this can be a very complex topic, feel free to pop me a message. And as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming video, I am going to cover the sealed class. And a sealed class essentially allows you to group a bunch of other classes together, but itself cannot be instantiated. Only the classes that are grouped inside of it. And this is great for basically just naming purposes. So for the sealed class, this is how you do it. Then in the name of the sealed class, so shape for example, in here you could have some classes for this sealed shape class, and let's say one for circle, and we could have this could have a radius, this could be a float. Then we can have another class square, and this could be the length of integer. And we could have a class for maybe rectangle, and this could have var length. Actually, no, width and height. So width, and this could be a float. And square, this could be a float as well. I guess I'll probably best if it's a float. Var height, and there we go. Okay, so now if we want to create it, we cannot do this. We cannot do var s equals shape. It gives an error. It says cannot access. It's private in shape. Shape cannot be, sealed types cannot be instantiated. So, but what we can do is shape, or the name of our sealed class, dot, and then the class that we want to use, circle. Then we need to provide a radius, so let's say 6, and the integer literal does not conform, dot 0f. There we go. And we could print it out by doing print line, or access any other properties of this class. The class could be as complex or as simple as you want, but obviously I've kept it simple. So we do s dot radius. Now if we run it, we'll get a result of 6. There we go, we get 6.0. So this is how you use the sealed class to group other classes together. Nothing, more to it than that. But if you have any questions, feel free to pop me a message. And as usual, I look forward to seeing you in the next video. Hello, in this video, I am going to show you extension functions. Extension functions essentially allow you to add extra functions to a class without modifying the original class. It sounds pretty cool, and honestly it is. So if we create a real simple class, I'll call it epic class, and this is gonna have a function. It's gonna be I'm gonna call it hello, and it's simply going to print something out. Again, the functionality of it doesn't really matter. And for this, what we are going to say is print line, Just gonna say hello world. That's all. Keep it simple. If we were to create a epic class, or let's call it epic of epic class, and then we could call that method like so. Nothing new here. We've done this a trillion, quadrillion, zillion times before. So let's just see our result, which should just be hello world. But to create an extension class or an extended class, you do it outside the class with the keyword fun, and then you put your class name that you want to add the function to, so epic class. Then you put dot, and then this is the function name. So I'm gonna say, oh yeah. So that's the function, and it could take parameters if you want to. That is essentially the same. Now I'm just gonna do a print line, but again the functionality inside of it can be however you want. I'm gonna say, oh yeah. And if I were to do epic dot oh yeah, as you can see, it disappeared. If I were to run this, we get a result of oh yeah. As you can see, the syntax highlighting is slightly different to indicate that it is an extended function, as it is over here as well with this, the look of it. So I'm thinking, okay, why would we put that there, not just put it here? Where is that useful? I'll tell you where it's useful. It's when you haven't created the class and the class is already provided. Maybe you're part of a large development team and you don't have access to that original class, so you can only create objects of it. This is a great way of extending the functionality using an extension function, or it's a built-in class, maybe some sort of data type in Kotlin, and that's what I want you to do. I want you to extend a class using the extension functionality of a class that's built into Kotlin. If you have any questions, because you might have any problems, feel free to pop me a message. Otherwise, I look forward to seeing you in the next awesome video. Hello, in this Kotlin programming video, we are going to look at generics. We're going to show you with functions, but you can apply this to classes as well. And as an extra task, I recommend, doing that, applying it to a class, and even extension functions. So if we create a little simple function, so if I create a function fun, and I'm going to say, I'm just going to say print. So it's going to be a very simple function. Literally, all it's going to do is going to take in some value. So it's going to be an integer, and it will. What does not like about this? Oh, val is not valid because it's already a keyword. So I'll put value instead. And if I just print line value. So just printing what's coming out. We could do whatever we want, but I'm going to keep it simple. And then if we call this method, it's expecting an integer. So if I pass in an integer, and now if I run it, we should get the value 5 printed out. 5. There we go. But maybe we don't want to pass in 5. Maybe we want to pass in, I don't know, a string like hello. That gives us an error because it requires an integer, but we have sent a string. So what we can do is use the generic data type. So before the function name, so here, if we put t like this, it's just saying anywhere that we have t, it is a generic data type. So where we want the date, or where we specify the data type, instead we put angle brackets t. And what about it does it not like? See if we try and run it. Something about it doesn't like it, so that is strange. That is strange indeed. Actually, no, I've just figured it out. You can only do this on collections. So, if, for example, sorry, if for example this was an array list, so if I did array list like so, and obviously if I were to pass in some sort of array list, so if I create an array list, so if I create a new var, I'll call it r equals array list of, and let's say it's of floats, and I put all the values here. Let's say 1.0f, 2.0f, 3.0f, 4.0f, and instead we are passing in this array now. So my bad. Now if we run it, obviously what we do in here, if we loop over it, if we put it into a database, that's totally up to us. As you can see, we get the values. If we created another array now, another array list, and it doesn't have to be array list, it could be any collection. So if I say AR2 array list of int, instead if I just do 1, 2, 3, 4, so it's just integers now, and that won't change anything because I haven't passed it in. Let's just run it again one more time, and then we'll have it printed out, but for the array2, which is integers. So that's how you use the generic data type. As an extra task, I want you to try and use it within a class. If you have any questions, feel free to pop me a message, and as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming video, I am going to cover ranges, and more specifically, integer type ranges. So, for example, if I create a variable, say I'll call it, range equals, and if we want this to, let's say, range between 1 to 100, you can do 1 dot 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 100. So this, has a range from 1 to 100. So that's pretty darn cool. So, it's something different. Not something you see in most programming languages. And if we were to loop over it, we could, do a for loop, which says something like for value in range. Now, if we were to just print line and just print out the value, let's just run it, see what we get. As you can see, it's got all of those values. We haven't had to create some, sort of array with 100 elements and then loop over it to assign, I plus 1 to it, I plus plus to it, or anything like that. You can also use this for strings as well. So you could use it for strings. So let me just quickly show you the string equivalent. So the string equivalent would be something like, character equivalent would be something like, let's call it R equals, let's say A dot 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 C. So this is just A to C, so A, B, C. So I'll leave this there, and we as an extra task to manipulate this in a loop and with everything else I'll do. I'm just going to use the integer range for now, but you can, you could use floating point numbers as well. Principle is exactly the same. So what I want to show you now is another way of essentially, looping over this, or different ranges. So imagine, I'm just going to comment this in just because it'll just be easy to see what we're doing in the console. If I did for, and imagine if I said for, value in, 100 down to 10. I think you can imagine what this does. It goes from 100 all the way down to 10. This is another range that we can do. If we print this out, it just saves a lot of time having to create other variables, arrays or anything like that to essentially accommodate this scenario. And we've been able to loop all the way down from 100 to a 10 without the use of any other variables outside of the for loop. So that's pretty cool. We can use the until range. So if we do for, let's say value in, so the don't know, 10, and if I say until 100. So now if I were to comment this one line out instead, or these lines, and here if I just do a print line, and if I print out the value, as you can see, we get all the values with until, so it doesn't include that value. So that's just something to bear in mind. You can also use a method called .range2. So you could also do essentially something like, I'll actually put it here within the comment. You could do 4. It's basically the same as this. So instead of saying for 100 blah blah blah, you could do for 100 dot down, and this is a method, down to. Essentially both of them is doing the same, and you could do one for range as well. So if I were to copy that again, the range is similar to the until. So instead of, let's say 10, you would do 10 dot until 100 or 1000, whatever the number is, and that's the same as what we've just done here. And you can experiment with these, test them out, and I recommend doing that as an extra task. So maybe, for example, we've got, this right here. Maybe we don't want to do it, in ones. Maybe we want to step it, so we could do step 10 and run it. And this works with all of these as well. A step does. As you can see, it steps in 10 now. So 10, 20, 30, 40. You could do in steps of 15, steps of 2, steps of 100, 29. It doesn't really matter. So that's it really for Kotlin integer type ranges. If you have any questions, feel free to pop me a message. And as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming video, we are going to look at regex. So what is regex? For starters, it stands for regular expression. Regular expression, it can look a bit daunting sometimes when you see some code for it online or some description. It's basically just checking if a string matches a pattern. That's all it is. So if we do a really simple example, so if I have var, and I'm going to call this pattern. So the pattern that we want to match against is you do it always equal to regex. So this is a built-in class. Then you say, and then the pattern we can do. So you pass in a parameter, and this will be assigned to pattern and the pattern. So before we do the pattern, let's create a string. I'm going to create a string. So var, I'm going to say str equals. It's always good to put the data type. There we go. And what we're going to do is check if there are 2 A's in there. So that's the pattern we're going to check for. Now, to actually essentially check if it matches, we just essentially do this. So I'm going to say var result equals regex. Pattern dot contains matching. And then we specify the input, and the input is the string, like so. And now if we were to print it out, so if I print out result, run it, let's see what we get. True, because AA is in there. Let's say if I put AF is not in there in that combination. So if we run it, false. What if I put, 2 uppercase A's? What result do you think we are going to get? We get false. Even though we have 2 A's next to each other, 2 uppercase A's are treated differently. They have a different ASCII code. I recommend checking out the ASCII table so you can see the codes. And it's always good to have an idea of what the codes are. Uppercase A is 65, lowercase a is 97. So, there are, there's a lot more that you can do with regular expressions, but the essence is this: that you have a string, you are checking for a particular pattern, and you'll be either true or false. You could start doing some crazy stuff if it contains this character, then this one afterwards, then maybe a space, or whatever it is. You can also use regular expressions to check the format of it beyond just a small pattern. You could do it to see if it's an email address. You would have to. So an email address would essentially have to be something like email at domain.com. If, for example, it was that would not be a valid email address. And there's other things that you could use it for, to check if it's a valid phone number as well. Not that it's a valid phone number in the case that it works, but the format is valid. But what I'm going to do is provide an amazing link that provides you with all information of the regular expressions in Kotlin. But if you have any questions, feel free to pop me a message. And as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming video, we are actually going to be doing some Java programming. Just something really simple. I'm going to show you how you can call Java code from a Kotlin file. So first of all, we need some Java code. So if you've either added a file, created a file, doesn't matter. I'm going to create one in the source directory. So right click, new, Java class. I'm going to call it epic class. In here, I'm going to create a method, public static, I'll do void, and the method name is going to be print. So we're going to keep it really simple. It's going to be system.out.println, and this is just going to print out hello world. To actually access this class, we just go to the Kotlin file, just do the name of the class, so epic class dot, whatever property we are accessing. Now if I run it, we get hello world being printed out. It's that simple. The method could be a bit more complex. You could have parameters in there. Naturally you can pass parameters through. You could have variables here. So I could create a variable public static int, and let's say if I have a variable called epic var, and if I go to the Kotlin file, if I were to do epic class dot epic var equals 9, then if I was to just do a print line of epic class dot epic var, we'll get 9 printed out in our little console right here momentarily. There we go. It's that simple. Obviously, the class, the method and the variables don't have to be static. They can be non-static, and you can create an instance of the class. And that is the same essentially in here as if it was a Kotlin class. So the code is interchangeable. You can do a lot with it. So if there's something that you either can't do in Kotlin, or you don't know, or maybe you've already got some amazing library set up and coded in Java, just import it in and you can use it in Kotlin. It's that simple. If you have any questions and you want some help, feel free to pop me a message. And as usual, I look forward to seeing you in the next video. Hello, in this Kotlin programming video, I am going to demonstrate how you can run Kotlin code, or call Kotlin code, I should say, from a Java file. First of all, let's create a Java file. You might already have one, you might be adding one, doesn't really matter as long as you have one. I'm going to call this epic class. And I'm going to keep it simple, but the principle will be the same regardless of what you're doing. I'm going to put the public static void main, so this is a main entry point. It'll have a string array, and in here is where we are just going to call our Kotlin code. So what I'm going to do is create a function for fun. I'm going to call it print, and it literally is going to do a print line of hello world. If I go to epic class now, to run it, you just do main kt, that's the default package, or if you have a different package, you can choose the package name, that is fine. Main kt dot whatever you're accessing dot print, and now if I run the Java file, As you can see, we get hello world. It's that simple. So if you change the package name, now obviously use the new package name. Easy way to find out what this should be. If you right click your Kotlin file, just go to where it says run debug. What's between the single quotation marks, main KT, that is how you will, refer to that file. That's it. That's really all there is to know. Obviously, you could pass in parameters here. If this function accepted parameters, you could have a class and access the class as well. And yeah, that's it. That's really all there is to know. Thanks for watching. If you have any questions, feel free to pop me a message. And as usual, I look forward to seeing you in the next video.